No te preocupes, Rainy.
Good evening, everyone. A warm welcome to all the 25th batch undergraduates joining us online today. Welcome to day two of the field selection guidance sessions, organized to give you clarity and direction as you navigate one of the most important decisions of your university life. Before we begin, a quick reminder to keep your microphones muted unless invited to speak during the Q&A segments. If you have any questions throughout the evening, feel free to drop them in the chat box. Um, okay, Tonight, we cover four major engineering disciplines: electrical engineering, electronics and telecommunication engineering, material science and engineering, and mechanical engineering. To kick off tonight's proceedings and officially welcome you all, I would like to invite Sahan Kurde, Vice Secretary of the Engineering Faculty Students Union, to deliver the welcome speech. Sahan, over to you.
Phải am I audible? Am I audible?
Yes, you are doing.
Okay, fine. So, good evening, everyone. I'm Sahan Kore, the Vice Secretary of the Engineering Faculty Students Union, and I'm really happy to welcome all of you to day two of our field selection guidance session. Over the last few weeks, so many of you reach out the FSU asking the exact same question, that is, what field should I actually choose? It's a huge decision, and we totally understand the stress around it as well. During our recent field familiarization sessions, you get a pretty good idea about what each department does, their activities, their subjects, and their curriculums as well. But we felt that is only half of that story. You also need to know what happens after your university and what the actual career paths look like once you graduate. So, to help you figure that out, we want to give you two different perspectives for each field today. We have invited a graduate who is working out in the industry, as well as a graduate who choose the academic and research pathways as well. So first of all, a huge thank you to all our guest speakers for taking time out of your busy schedules to be here and share your experience with us today. We truly appreciate it. To everyone here, make the most out of this session. Don't hesitate to ask any questions. Ask your questions by chat box in here. So enjoy the day too. Thank you. And it's over to you, David.
Thank you, Sahan, for setting the tone for tonight's session. Choosing your specialization is about aligning your passion with industry trends and higher study pathways. To help you make an informed choice, we have an exceptional lineup of alumni tonight, industry leaders and top researchers joining us from across the globe. Let's get straight into our first department of the evening. Kicking off day two, we have the Department of Electrical Engineering to guide you through the field, industry, and research avenues. We are honored to introduce our two resource persons, Mr. Pasan Pethiakoda, a chartered electrical engineer and lead railway signaling power engineer at Alstom Transport UK. He brings over a decade of international experience in electrical design and control systems and is also the co-founder of tech startups Yuga and eGear Zone. Mr. Ravin De Silva, a first-class UOM electrical engineering graduate and currently a PhD candidate at the University of Technology, Sydney, Australia. He is a visiting researcher in France and Switzerland, specializing in hydrogen energy systems, fuel cells, and microgrids. Over to our EE speakers.
Thanks a lot, gentlemen, for the introduction. So, could someone please confirm that I'm audible?
Yes, sir, you're audible.
Thank you so much. Let me share my screen. I'm really sorry, my camera is at a weird angle, but that's where it usually sits, and I don't want to change my arrangement slightly. But thank you so much for inviting me. And in the meantime, please let me know whether you can see my screen. Let me share some photographs and be quickly within the next 10 to 15 minutes to give you an introduction on how my engineering career looked like, which steps I took, which path I followed, and possibly the other opportunities, other avenues you could follow, which are related to what I have done in the past. So, starting with, I'm really grateful to University of Moratuwa and certainly to the Department of Electrical Engineering for because of which who I am today. And certainly it has helped a lot in my career. I believe if not for Moratuwa, I won't be here. Right. So let's move one by one. Why did I end up studying electrical engineering? I liked heavy machines and programmable logic controllers. That was my passion. Now, not like in our days, which is I did my advanced level in 2008. So compared to that a decade ago, you guys have a lot of more exposure to engineering stuff around the world. So in our old days, we saw things like heavy machines, programmable logic controllers was the closest we know when it comes to control systems, and I like them. Number two, I like programming, but something with hardware. So I did not just want to do software. I wanted to do programming, which is related to hardware and something workable. So it was close to robotics, but I wasn't, I would say, smart enough to do robotics. So robotics wasn't my passion. Instead, I wanted to control machines like motors, motor drives, and control machines using software. That was my passion. And I also wanted to see a balance between being in a boardroom or in a office environment, in an office attire, at the same time hitting the ground and doing some hands-on work. In the next few slides, I'll show you some photographs of my life starting from, I graduated in 2014, completing electrical engineering, and now in 2026, so it's a little more than a decade, what I did over the period of time in a couple of snapshots. So I started as a site engineer. So usually images talk 1,000 words, so I would show what I did in a couple of snapshots. Apologies, they are not very descriptive because I had a limited time to prepare, but I tried my best to capture some photographs from my old Facebook, not really old, but Facebook profile to show you where I have been, and some of the photographs were, I was actually posing because we had you would have the same intention of posting things on social media when you start working. But with time, when you grow old, you lose the interest. So I used to post back then, but I don't do anymore now. But it was useful because after a decade, I still could go back and look at those images. So I worked as you see on the right hand side. I joined the company called Celex, first LTL Projects, then became Celex Engineering, and I worked in the automation department. So my task in the first few projects I worked was spillway automation. I worked in Rajanganaya, in Kaudulla, in Daduroya, in the dry zone, making manual spillway gates automatic and manual sluice gates automatic, and introducing a PLC-based control system to these sites. So what you see on right-hand side is Kaudulla when I was working there. With the site engineer, the life is definitely challenging. I would say it's good when you are a bachelor, because people like myself now, I'm happily married to, and got a daughter 2.5 years old. So I still go to site. I have to, but the problem is I still have to come back at least on weekends and a lot of family responsibilities. So the best is to be a site engineer when you are a bachelor, so that you can be on site months, if not for years, and you are coming back home is not really a mandatory requirement frequently. And I see being a site engineer as a good stepping stone, because that gives you the opportunity to do hands-on experience. This photographed on the left-hand side here is when I was working in Mullaitivu. We did a water purification plant for Mullaitivu, and we did it for the first time, I think, the post-war period. And the project started kicking off in the war-affected areas. And this is when I was in Mullaitivu programming a VFD. I think it was 11 kilowatt variable frequency drive in the background, an ABB one. And the cat was a friend of mine when I was working on site. So sites are something like that. You find a different life. You are sometimes isolated away from home, and you do have a small community of people working on site. So it's an interesting life if you want to pursue. Preferably do it when you're at your early stage of your career. What you see on the bottom down there is to give a glimpse of an understanding. Even though you go to site, even though you talk about heavy machinery, and even though you talk about heavy equipment plant, you do have a scope for software programming configuration as well. So this photograph on the bottom, actually it was a frustrated moment, because this was captured in Moragahakanda. We were deploying a SCADA there, where the Moragahakanda was, we wasn't involved in construction. That was done by a Chinese party. We were only involved in improving their SCADA. And what we realized is a frustrating moment, because the SCADA was majorly in Mandarin with a little bit of English there. So we do have to guess certain things by looking at the numbers and going back and forth and doing the programming calibration to make sure all the instruments we have installed and what we have installed in SCADA do work properly. So this is what I've been doing for about good 6-7 years. And I did mention that it will be definitely challenging. And you might wonder why this photograph here. I don't know whether any one of you come from the Chilauputlam area, or anyone familiar with Vilpattu National Park. This is when I was trying to travel from Colombo to other side of one side is Mullaitivu, the other side we had another plant called Mulankhawil. We were trying. I was trying to travel there, and I was expected to drive. I was given a double cab to drive my own, and I used to drive through the Vilpattu National Park instead of taking the route around close to Anuradhapura, because the path is shorter. It's shorter, no mobile signal, even though you go through a couple of Navy camps, and you do get to cross both coming from Rajangane. If I remember right, it's Daduroy. When Rajangane spills, the Daduroy spills over, you got to drive through bridges like this where the water spills across them. Nice scenery, wildlife at the same time. It's risky. Not that I used to do too many risky things there. You do follow health and safety standards, but at the same time, this involves adventurous stuff. So if you decide to be a project engineer, be ready to accept challenges like that, and be ready to accept challenges like that. I'm not discouraging girls from taking site engineer roles, because I know a couple of girls who did really well in sites. Of course, with families, they did with families getting heavier, they did pull out and preferred desktop jobs. But they have been doing exceptionally well when they were on site. And then a bit of experience from UK. I think everybody should, well, I recommend rather, if there is an opportunity, go work abroad at least once in their lifetime. Exposes you to stringent work standards and gets the opportunity for you to work with the latest technologies. And a couple of images again from the right hand side corner is what I do. The truck is next to me. I am a railway signaling power engineer. So my day job right now in the UK is to make sure in projects we do have power distributed along the railway tracks. Well, this is not for trains to run. This is for the signaling, telecoms, communications, level crossings, all along the railway tracks. All the all the trains run here in the UK do speak to the controller all the time. They do obey. They are monitored using radar connections. All the level crossings are protected by automated barriers, and it's an automated system which is very live all the time. So my responsibility as a lead power engineer is to make sure that in all the projects we do, the truck should be live, truck side should be live, so that all the communication signals are available all the time, which is a very, very safety critical supply. So we usually use about 4 different power sources to supply a single load, just to make sure that the power is available every single time. As you can see, my job involves a lot of switching and always involves a laptop, and my bag is always full of communication cables as well, because you have to be ready to plug into any sort of a communication system whenever you go trackside. We do work with a lot of numbers, SCADA programming. What you see on the what you see below is programming a SCADA system to pass on information into the railway signaler. We do night shift, photograph captured during night shift, what you see over here. So we do have to do night shifts a lot because railway track is live during the daytime, so you have to go during night time to work if you want to work close to track, because otherwise it's a safety hazard. So at this age as well, I do have to go to site, not that frequently as I used to be when I was a bachelor, but I don't see, like, for about another decade, I might have to go to site at least for a period of time. The reason why I said you get an opportunity if you work abroad to the latest technology is on your left hand side. You might not see me sitting there, but this is a conference in Brunel University. They do invite us to share our thoughts, experience, what we do on site. And there was another picture I couldn't find. You might have heard of a software called ETAP, a globally used software for modeling power systems. So they had a conference in London, and because we use ETAP, they invite ETAP users to come there and share their thoughts. I got an opportunity to be a part of their conference in London and share my thoughts on ETAP, as well as see what we see challenging in their software, how we think it would be very beneficial if they change the software. So being abroad and working abroad usually expose you to stringent safety standards, stringent regulations, stringent technical standards. At the same time, you get the opportunity to work with global companies and expose yourself to more challenging situations. So that's what I do as an electrical engineer. So if you are interested in pursuing a career of this nature, do hands-on experience, do work hands-on work as much as possible. You do get the opportunities during lab time. Do not waste it. Work in the lab as much as possible. It's not just submitting a report. You need to understand what you are doing when you are inside a laboratory. And when you are an apprentice, we call it here, or when you get the industrial training, use your industrial training time as much as efficiently possible. Not just spend the 6 months somewhere, but to study actually, to get something out of that. I was a trainee in South Asia Gateway Terminals, and that's actually I started working with the motors and programming controllers when my first time, and that was very useful for me. So never waste your training time. Do as hands-on as much as possible if you want to pursue a career like this. Other avenues open for you. You could join a design and consultancy firm if you don't want to be on site. You don't have to be on site as much as I do. If you go for a design and a consultancy firm, you could take up a role as a plant maintenance engineer, which is good as a stepping stone, which I don't recommend long term. But if you go to a factory as a maintenance engineer, you do get exposure a lot into maintenance of machines, maintenance of plant, and keeping a plant alive as much as possible. That's also a career if you want to pursue. You could pursue a role as in project management as well. A lot of engineers do prefer taking roles in project management and then advance themselves in the corporate sector, which is also a possibility. I myself studied management accounting. I am a certified management accountant in Sri Lanka. I did study ACCA as well. I could not complete it. I should do it. Something I need to do before more hair goes gray. But those are the roles in my area you could do if you don't want to go to site and be on site all the time. And so during a university, enjoy your uni life, collect experience, gather memories before it's too late, because you need to study, you need to work at the same time. The 4 years, it would run fast. It would fly before you even realize it. I was a president of Gavel Club, vice president in Electrical Engineering Society, member of Classical Music Society. Left hand side is when we used to compare Yatra. It's happy to see that Yatra has grown leaps and bounds. It's a fantastic show now. And do travel with your colleagues, organize events. I think right hand side is from Electrical Engineering Society organized We Are With You, along with Deaf School in Ratmalan. I don't know whether we do it anymore, but then there's the board members of Gavel Club. We used to have fun. And so be in societies, work with people, do sports, something I missed in the university I should have done. Travel around with your friends, enjoy the university life. So this is my career in simple terms. So let me stop sharing. If you have any questions, clarifications in the chat, I don't see anything there. So that's pretty much what I do. If you like pursuing a career like that, start hands-on work, hands-on experience, because that's what actually matters. So thank you, ladies and gentlemen. Unless we have any further questions, I believe I could finish between like 13 minutes.
Yes, guys, if you have any questions, you can please you can type in the chat, or you can unmute and you can ask yourself. Okay, so thank you, Mr. Pasan, for that excellent industry perspective. So next, to give us an overview of higher studies and research pathways in electrical engineering, let's welcome Mr. Raveen De Silva. And like I said before, Mr. Raveen graduated with his first class honors from University of Motua and is currently a PhD candidate at the University of Technology, Sydney, Australia, as well as a visiting researcher in France and Switzerland, specializing in hydrogen energy systems and fuel cells. Mr. Raveen, over to you.
All right. Okay. Yep. Let me share the screen first. Submit. Okay. Are you able to see my screen? Yeah.
Yes, sir.
All right. Okay. Sorry. So, hello again. I can see so many people over here. Hello again. I'm Raveen De Silva, and I am doing my PhD in electrical engineering in University of Technology, Sydney. So, and I'm also at the same time I'm working as a visiting researcher in France and in Switzerland. So I'm just gonna go ahead and explain a little bit of things I'm doing and how my journey came from from university, from Department of Electrical Engineering, and how my experience from the university in my department, how that helped me to to achieve stuff. So first of all, thank you for inviting me, and also thank you so much, Pasana. Yeah, I think like when we were in the first year, we had so many so many sessions, like so many introductory sessions from people like Pasanaya, from very good alumni from our department. So because of those people, they like because of those people, we got the motivation to come to the electrical engineering department and like to study and to be curious about electrical engineering. So thank you so much, Vasana. Yeah, so yeah, let's move ahead. Um, yeah. So who am I? I I actually I completed my bachelor's degree in electrical engineering with a first class, and I was at the top three of my department, like when I passed off from my department like in 2023. So I'm pretty close to you, as in age, as I think so. So I was a research assistant when I was in Sri Lanka, like just after I completed my studies back in 2023. I joined the department and I was a paper lecturer. So before I started my graduate studies in Australia. So my experience is specifically in renewable. When I was back in university, in my department, so I worked on microgrids and more like renewable energy. If you are not familiar with the microgrids, it's more like the grid. Like let's say if you have the power grid, it's more like a centralized grid. So it's sort of a new term right now, but anyway, let's move ahead. So it's just after my studies, I was very lucky to obtain like a PhD scholarship, like few scholarships from Australia and also from France, to join Australia as a PhD student, as a researcher in France. So I was really lucky for that one, for those achievements. And currently, as I said before, I am a final year PhD student from University of Technology in New York, and my research area is basically on hydrogen fuel cells, which is kind of a new thing if you are not really familiar about. But I will try to explain it as much as I can. So at the same time, I'm a teaching assistant in my university in Australia. So moving ahead. So what do I do? Um, this is I want to spend a little bit more time in this in this slide. So in fact, I let's say if we keep the studies aside, like if we keep all the academics and all the academic and technical stuff aside, I do like to hike. I like trekking, traveling, and also volunteering. So basically, yeah, when I was in Europe, I tried to travel a lot, and I did so many mountain hikes and climbing all around the Alpine mountain range. So let if we keep that aside, my thesis title is basically working on reliability assessment of fuel cells, hydrogen fuel cells for backup power systems. That is, in fact, if you if I if I say in very simple words, let's say you guys know about the hydrogen atoms and oxygen atoms. So in fact, if you know with our A-level chemistry and A-level physics knowledge, we know if we do electrolysis on water, we can get the hydrogen and we can get the oxygen, we can get the hydrogen and oxygen. So how what would happen if we reverse the process? Let's say if we give the power, and then we can get like the hydrogen and oxygen. So if we reverse the process, we give hydrogen and we give oxygen, and then we get energy. So that is basically the principle of the fuel cells. and it is currently very much being applied all around the world. So especially in Australia and especially in Europe. So that is basically my research area. So for this, as I told you, like electrical engineering is very vast. So as Pasana also has mentioned, so in electrical engineering we study from lightning. You know, the lightning strikes from 10 kilovolts, like millions of kilovolts, like very high voltage, and also like we study into like very nanoparticle, like nano level semiconductor voltage. So all the way from like high voltage to very miniature nano type voltage, we study that in electrical engineering department. So in my area, I study more on electrochemistry and applied electrical engineering, and also like reliability engineering. So that is where my research expertise is in. So when I was in Europe and when I was in France and Switzerland, I was able to do very successful experimental campaigns for the past 12 months, and we are currently pending a few patents and few publications. So for our work, that has been good exposure for me and for the industry. So yes, uh, yeah. Just a little bit more ahead, like I took this slide from one of my one of my uh, other presentation. So as I told you, hydrogen energy is quite a new, not actually quite a new but new thing, but it's kind of a it's kind of a buzz thing right now, like buzzy thing right now. So that means we have the hydrogen, yeah, as you can see on the leftmost diagram. So we supply hydrogen and we supply air, and then we have a membrane. So we will be able to like generate an electrical current when we supply hydrogen and we supply air. So basically that is electrochemistry, like we have an electrochemical reaction happening in the membrane of the fuel cell, and with that we'll be able to get some get some current and get some power output. So in fact, this is quite popular right now, and right now so many companies, including Microsoft, including Nvidia, and so many power companies, for example, Energies in Australia, and so many other power companies, they are currently using hydrogen fuel cells. Um, and also at the same time, how in Europe and especially in Switzerland and Germany, in France, they are using hydrogen fuel cells to run trains, to run buses. Their public transport is what we have in Sri Lanka and what we have in many other countries, including Australia. We have either electrical energy, like electrical batteries, lithium ion batteries, or either like internal combustion engines, diesel or petrol. So with this, when we use these kind of fuel cells, we will be able to like generate power very cheap, like not very cheap, but very efficiently and very environmental friendly power generation through hydrogen fuel cells. So that is a little bit of what I'm doing in my research area. So moving ahead, this is all my work for the past 12 months, and I have been able to build this from ground up, and I was able to do my experiments in France. So with this, I'm expected to get good results, good new findings, and now very good contributions from my research area and to the science. So yeah, let's quickly move ahead. Right. So coming to the main point of the session, I hope I'm on time. So yeah, basically I want to highlight why you should invest your time and your and your energy, time and energy on electrical engineering. So how is the concept of electrical engineering, and how that can matter to you. So basically, with uh, current like emerging population. So all the countries, they have a like increasing population. Because of that, increase in population means increase in demand of electrical energy. So that means maybe like when there is more population, they need more energy. So because of that, like we need energy, like we need power systems, like we need power systems to sustain the like power demand. So it is never ending. So that means like every day you move ahead. In the like in the near future, we need more power demand. So more electrical engineering, like electrical demand. So in that case, if we consider that, we also need new electrical engineers to take up the mantle. So let's say we have so many nuclear power plants in France, and they're kind of like they are training new electrical engineers to like take up the responsibilities of the nuclear power plants. Same as in Australia, same as in other European countries, same as in US, UK. So we need engineers. It is like, there are so many experienced engineers, but electrical engineering is not really hard. So it comes with so many responsibilities. So for example, if you're an engineer, if you're an electrical engineer for a region, so you have to be responsible for for the power demand, for like for people's lives basically. Like if you have like if there is some like let's say hospitals and all the stuff, so you are basically responsible for their lives, the patients' lives. So it is really it's really important that you learn engineering, specifically electrical engineering. So as I told you, it is the demand is forever increasing. So at the same time, why you should why you should focus more on electrical engineering and then renewable energy. So basically, renewable energy, if we consider it is kind of a kind of a not new thing, but like we have solar panels, we have like a wind power plants, and we have so many energy storage options, which is not currently in Sri Lanka right now. And there are so many other electrical renewable energy power systems, like let's say wind energy, wave energy, uh, like so many other geothermal, etc. So we have to manage, we have to, if we have so many power sources, let's say solar, wind, batteries, and all the so many power sources and power storage systems, we have to have they have to work together. So that means if we consider wind energy, there's obviously mechanical engineering, electrical engineering, like everything combines together in a wind energy system. And when it comes to solar energy, we already have photovoltaics and so many optical engineering, and then also mechanical engineering, electrical engineering. So it's electrical engineering is not one thing. Let's say you can't say it's only power systems. It's only it's not always like the V equals IR. So it's a lot of things together, like combined together. So if you consider a renewable energy system, there are so many subsystems sub electrical engineering things you can see on them. So yeah, I mean basically that's it. So right. So I want to highlight from this in the in our lives in Department of Electrical Engineering. I think Pasanaya gave a really good good introduction on how our lives are how how do we do social things. For example, like we do so many volunteering activities in our department. So I haven't included anything in this presentation for that, but I think Pasanaya did a really good job explaining them to you. So exactly, it is a good place to learn. It's a good place to experience. If you are passionate about electrical engineering, there are so many things you can learn, so many things you can do self-learn, and we have a really good staff at electrical engineering department. So, but the main thing, when you're choosing when you're choosing which field, whatever field you are choosing, you have to be passionate about it. So when I was choosing electrical engineering, for me the passion was on the lightnings, the high voltage lightning strikes. I was really curious about the lightning those days. So yes, I need to highlight you have to be passionate about it. So at the same time, if you are passionate, you have to you have to have some livings. You have to find a living through whatever you are choosing. So there are so many options, as I mentioned before. As Fasan I mentioned before, there are so many opportunities in renewable energy, like renewable energy systems, in machines and drives. And there, as I told you, there are so many things you can explore in electrical engineering. Uh, yeah. So my area, higher studies and the support from our department. So if you have been to electrical engineering, the field familiarization, the sessions, we have a very dedicated microgrid laboratory. I myself worked there for when I was just completed my final year examinations. I I worked in the microgrid laboratory and I worked with those equipments, and that was a good exposure for me. When I go before like when I go to the research research world, I was able to get very good exposure from the Department of Electrical Engineering, and that really helped me to to learn stuff and to apply them in my work. So right, so as a take home thing. So I really agree. You have to be a balanced graduate. So whatever field you are choosing, like maybe electronics, mechanical, materials, whatever, electrical, whatever field you are choosing, you have to be a balanced graduate. Do sports, do some societies, yeah, do some societies and get the in-depth knowledge. So just don't do examinations and just don't do assignments for the sake of doing the assignments. So I know the grades are really important. At the same time, whatever you learn in those studies, like whatever you learn in those modules, you will see them applied in real life. Like when you go to the industry or when you go to the academia or industry, you will obviously see them applied in the real life. Even the small mathematical equations you learn in the math modules. So you will see applications of them really like in real life in most industrial applications. So yeah, as I told you, academic grades are really important. Yeah. So I really want you to highlight you can have a really fulfilled university life through electrical engineering department. And I guess if you have any questions, I can answer it right now. So I want to highlight again, whatever field you are choosing, maybe whatever field you are choosing, you have to follow the passion. You have to follow what you like. And I wish you all the best. If you have any questions, I'm really happy to answer.
Okay. Thank you, Mr. Ravin. Thank you again to both our speakers for your valuable insights. Next, we move to the Department of Electronics and Telecommunication Engineering. First, to share his journey across academia and entrepreneurship, I'm honored to introduce Mr. Deepana Istavira. Mr. Deepana was named the most outstanding graduate of University of Montreux in 2022. He holds an MSc with distinction from ETH Zurich. He is currently pursuing his PhD in robotics at ETH Zurich and is the founder of deep tech startup Robotic Gen. Mr. Deepana, we are excited to hear from you. Over to you.
Right. I hope I'm audible.
Yes, sir.
Okay, thanks. Okay, so let me also share the screen. Right. Okay. Yeah, right. So, I think first of all, I have to thank for actually like inviting me to talk like all the youngsters. I think you guys are the next generation, and we are kind of like the old generation now. And actually, we have been in your spot before. So in my case, actually, like 9 years ago, I was in your spot. So basically, I was in like, I mean, I was like at Moratua, and I finished my kind of exams, and I was going to select a department, right? And actually, I chose to be in the electronics department, and that is where my journey in robotics started. And this is where I currently am in the state of the art in robotics in the whole world. So I thought rather than giving a general advice, I would share my journey because it would inspire any one of you. So then you will be the next generation, and then you will be the successor, right? So, right. So actually, Department of Electronics and Telecommunication Engineering is actually a very vast field, right? It covers so many things, but I'm mostly focusing on robotics today because we also have another speaker who's also expertise in telecommunication side, right? And also the AI side. So I will focus a bit more on robotics and then try to share my journey and the lessons I learned, and then some tips at the end. So please listen carefully because there would be so many things for you to get out of it, right? Right. So first, starting off with the title, right? So the title is Journey of Becoming a Roboticist, right? So what does even a roboticist mean? Because in the age of AI, I think everybody knows about AI. The next step, the next stage of AI becoming physical is robotics, right? So that is why this field is so important. And this is not just one field, which I will explain later. So a roboticist is someone who love to learn about robotics, who's like really going on YouTube and like try to search for the latest videos, like try to look up online, and who would try to like build things, like build robots from scratch, try to build new robots that can solve different things, and also who would love to share. So I'm also trying to be a roboticist. I'm also in the journey. I haven't finished yet, but I have come some far. So I have experience professionally working with kind of good robotics companies. I know state-of-the-art robots, and most of some of the videos that you would see online, I actually have seen it before, kind of before they publish it. So that is kind of a nice privilege that I currently have. But all of these started in the journey at Moratua, right? So, and then I'm still really grateful that I think there's small, yes, thanks. So like all of this, I'm really grateful for like electronics department because that is where my journey began, right? Okay, good. So to even start on the things, maybe like let's dive into a small robotics video, right? Yeah. So like here you see a parkour video, basically a robot like trying to go on top of a box, and then it just jumps off it and then comes down, right? So in this one, right? So like in this one, there are so many different aspects to it. It's not only one thing, right? So that is many technologies. So there's of course like hardware, right? There's also of course embedded, there's software, there's like AI, so the brain behind the robot, which is kind of reinforcement learning in this case. And then if you see the iPad, and then we can see live and then kind of give a goal to the robot. So that means we have virtual reality, we have mixed reality. So robotics is a very nice example that kind of bridges everything from hardware to software. And that's why I think this is so cool, right? And even though the state of the art robotics is this, and what we start in Sri Lanka is basically here, right? This is where we start. So like here in the middle, you can see my first ever robot during the Sri Lankan Robotic Challenge, which is actually organized by the electronics department, which is the department I'm from. So this has been the turning point in my life, like trying to find this new passion. Because before I came to start my degree, I didn't even know about robotics. I didn't even know what Arduino is. I had to learn everything from scratch. But from this competition and all the undergraduate competitions, it unlocked a new passion in me, which is robotics, right? So I was able to build so many robots during my undergrad, which is more than 20. And then I had to learn everything by myself. There are some courses also in the degree program where you can master mainly on the second, third year, but you can also learn everything by going to competitions. So those days we participated in many robotics competitions, in many competitive programming competitions, hackathons, and everything that just came in. And then it was a very proud moment after I graduated in 2022. After 2 years, I could actually come as a chief guest for the same competition and then start sharing my journey with everyone. And I actually showed again the first ever robot that I made, which actually won the competition. We won the third place, but it was not the very best one, right? Okay. So I think as everybody else, like all the guest speakers who are really good, so they also mentioned, right? So kind of during the university, it's not only about studies because academics is only one thing. Okay, even though I got the kind of gold medal, but still it's not the majority part of your experience during your undergrad because this gives so many opportunities to kind of explore more, right? So even during my undergraduate studies, I also did like many extracurricular activities, like trying to gain kind of leadership skills, technical skills, trying to like come up with new things. And then you can even like see like our next speaker also like here with me in this picture, so that you will hear more from him on his journey. Sadushan, my friend. Yeah, so there's so many other things as well to explore, right? So to share a bit on my next step, so because like after my studies, I was so interested to kind of learn more about robotics, right? So I think you have seen like this very recent video, which was by Unitree. I will not play like I can try to play it, but yeah. So like I think like you have seen these like very crazy videos, right? And basically, all of these kind of new robotics, like basically Lego robots, so the kind of robots that can move, can be humanoid, quadruped, or whatnot, they unlock. So they actually do these capabilities because of reinforcement learning. And I was very interested on joining the best lab in the world for this, and which I really could because I worked so like I think the main reason that I could actually get into so one of the top universities after my bachelor's because I worked so much on my like on our own on going for different competitions and so on. So that experience during the undergrad helped me to actually get into a place where I can learn the state of the art in robotics, right? And something that I want to tell, because this is from my personal experience, I thought coming from, I mean, like basically like coming from Moratuwa and then joining ETH, which is like in the top 10. And then, I mean, we know like our Moratuwa University is ranked in the top 1,000, right? And then I thought like this change would be very tough. But what I really understood at the end, so like if you work well during your undergrad, that change is not really much. And then it's even easier to stand out because like everybody else like has everything when they start, like they all have like they have all the hardware and they actually have a safer start. On our case, we have to like learn everything on our own, which actually was very helpful to like stand out from the rest and then do something impactful or even at a global scale. Right. Also, I want to a bit share like some of the nice experiences like in Switzerland. So it's actually a very beautiful country. So like it's also called a Silicon Valley for robotics. I mean, we all know about kind of Silicon Valley, which is in Boston, right? So like which is in California in US, right? And then, but for robotics, so now the heart is becoming Switzerland. So there's so many cool things that I have seen. Like most of the robots that I see online, I could also like meet like in person, which is kind of very cool. Right. So a bit I want to share about the next era, I think, in like mostly hardware and AI, because we know that like now software is mostly dying out, right? Because now with AI, everybody can code. It's only matter about your idea, right? That is the most important thing. And right now, the next stage is becoming physical AI, right? So that means robots start to solve more important and more impactful and harder problems. Like here you can see even like couple of different examples. So now there's actually a big trend in like humanoid robots also solving industrial problems, like problems in urban scenes, in your home. There's like kind of robots built for like last mile delivery, or like kind of drones that can surveil an environment and then help first responding, right? Or even in entertainment. I don't know whether like you have seen like Olaf robot in person or like in the internet. It's so cool, and this is only unlocked by the latest advancement of AI, right? Okay, and I also want to a bit share about my like entrepreneurship journey, because actually 3 years ago we started a startup called Robotic Gen, and then the main motivation of building Robotic Gen is to actually make Sri Lanka kind of compete with like state-of-the-art countries with both robotics and AI technologies. So when we started this like 3 years ago, we thought that we don't have enough expertise in Sri Lanka, and that's why we started our own academy. And we even start at the age 8, not even when you're at university, because I learned at university, but it doesn't mean that you have to learn at university, right? So we start our journey for our kids, like trying to build the next generation tech leaders, even at the age 8. And then we also now have our Robotic Gen Labs, which we actually try to build state-of-the-art cool stuff, right? So it could be in IoT, robotics, sensing, embedded, and whatnot. So that is the main journey. And the other thing that I want to highlight, because I think in university, like sometimes maybe the kind of new generation, you like to work alone. So alone you can go faster, but I think as a team you can go far. So in my personal journey, like I try to like work with teams, like build teams, go for competitions, like try to work towards a common mission. I think these are really helpful for you to do more, right? Not only do studies, but like try to balance your studies with everything else. Right. So for take home, so there are 3 things what I want to mention, right? Okay. So if you're into robotics and AI, I think electronic department is where you want to be. That I can be sure, because like here we have good alumni ecosystem, we have previous projects, we have expertise there. I mean, we also do, I think, joint collaborations. We also do final projects together. So it's a good thing. But I mean, I know that like your department is only selected from your GPA, right? And the GPA is not the end of the world, right? So like, even though if you don't get into your dream department, it could be NTC or whatnot, it's not a limitation, right? So, but don't limit your department, like kind of limit your ambition, right? So like if you want to do robotics or AI, I think in any department you can still do, but it's on your own, right? So, and the other one that I also want to highlight, because I mean, when we open for a position or something, like recently we opened and something, and then we got like more than like 100 applications, right? But even in the 100, like actually good candidates are only 3 or 4. So try to build a portfolio, not only a transcript, right? A portfolio could be both extracurricular activities, co-curricular, and whatnot. And the other important thing, I think also previous speakers highlighted, try to find your passion early on. So for me, I found my passion very early on, and then I stick to it for 9 years. So then I can become an expert in that field, right? And the other thing, start before you feel ready. So those are the 3 things I want you to take home, even though you're joining ENTC or whatever department, these things will help you to build a very good career. Yeah, thank you so much.
Thank you, Mr. Deepana. So, do any of you all have any more questions? You can unmute yourself and you can ask questions yourself, or you can drop a text in the chat. So, whichever do you prefer, you can ask any questions right now. Okay, so with that, moving on. Now, to share insights into research, machine learning, and graduate studies, let's invite Mr. Sandushan Ranavira. Mr. Sandushan is a first-class ENTC graduate and a PhD candidate at the University of Technology, Sydney. He has published 4 Q1 IEEE journal papers and is also the founder of the Danuma Yatra initiative. Mr. Sandushan, over to you.
Oh, sorry. Am I audible?
Yes, sir.
Yeah, okay. Thank you. So let me share my screen first. And yeah. Can you see my screen? Oh, I think I pushed the wrong button. Yeah. Can you see my screen?
Yes, sir.
Yeah. So yeah. So before I start, I first like to thank the whole Engineering Faculty Students Union for organizing this thing, because in nowadays actually we haven't have something like this. It's quite good to see some nice initiative from Engineering Faculty Student Union, and also inviting me to share my experience with these fellow young graduates of the University of Moroto, who are the future of our country. So yeah, so in my talk, actually, I'm going to some brief academic overview of the ENTC and see how you can build an academic profile which enables you to go to higher studies and the research journeys inside ENTC. So I'm basically focusing on which options have you available and which accomplishment that our previous graduates and our batches have been made. Yeah, so before going into my discussion about my faculty, I will discuss a bit about the field selection decision. Because I need to highlight, it is basically bit important decisions in your life. So basically, because you have to think very carefully about your choice, because it can be deciding that what we're gonna spend your rest of your life with. So basically, this can determine what your future 50 or 40 degrees or 40 years of your life is gonna be. Of course, you can change the fields, but based on this decision, it's the first place that you make a decision that which field that you're going to move forward to. And also, as previous speakers have been mentioned, you have to follow your passion and understand which field is best for you to build a career on. And also, other thing is, although you have get more information of these sessions, I think you have get pretty much more information from the other speakers and including my colleague Deepana as well. But if you need to get to know more about the department, please feel free to get in touch with the seniors, alumni from each department to get to know more before making an informed decision on yourself, like which department that you need to go. And the other thing that I need to mention is, in this process, if you get your first preference, that's great. But if not, do not worry, because you can always make it work. Because I need to highlight that even though the department tell you some sort of a name as your field name, all of these fields are interconnected. So you can always find your passion inside the department that you get selected, and you can build a career on. As I mentioned, I think Deepan has mentioned, this journey is not about a transcript. It is building a portfolio. So no matter where you go, depending on your GPA or something, it is, please remember, you can always find your passion and make it work. And at the end of the day, the right choice isn't the best department. The best department is there's no best department, or there's no best fit for all. The best choice for you is the department that can shapes you for the best version of yourself. So basically, pick the department where you think you can be your best version. So do not make your decision based on others' opinions or majority of opinions. You have to make your decision on yourself. Even the things that we talk about our journeys, like thinking yourself and take your own decision on it, because sometimes things are good for us may not be the good things for you. Okay, having that said, I will just explain about the pathways that you can available in the our electronics and telecommunication department. So basically, we have communication and networking. So that I belong more. So basically, where you get to know about things like Internet of Things, communications, networking. So you need to know about how this digital communication system operate and how this networking system or telecommunication systems operate. So basically, that is one major field that you can go in the electronics department. And also, as my colleague Deepan has mentioned, that he has a great journey in robotics. So if you are interested in robotics, there are two main streams that you can take in the electronics and telecommunication engineering department. And also, if you are interested in electronics, there are you can focus on electronic product design, you can focus on IC design, and you can focus on refined electronics design, and also you can focus on embedded system device. And also, if you're focusing on AI or computer vision, there's a stream would allow you to do computer vision and pattern recognition inside that one. So it is actually taught by Dr. Sadeep Jayasumana, as I remember. So he's a former researcher at Google. So he has a vast experience on these AI and computer vision technologies. So basically, these are not the things that I just hypothetically put in there. Basically, this is the exact 9 streams that you have to study inside the ENTC curriculum. If you take any of these streams, I can pick even my batchmates that who are having PhD degrees in the world top universities currently. So at the end of my talk, I will briefly let you know what are the universities that our alumni are right now. But if you are interested in any of these fields or any of these buckets, you are feel free to choose ENTC. But again, it's the choice that need to make by yourself, depend on your passion. And if you think that is a good fit for you, feel free to choose. Okay, now I will give me some my personal reflection on ENTC. I think as you all might already know, I think if you follow my social media profiles, like I publicly share that aspect as well. I was a below average student at my school. So I was not a top student at my school from my childhood, but I just started to my academic journey as a best, somewhat good student in the last 8 months of my A-level examination. So I somehow get 3 A's and then come to the university and then manage to get selected into ENTC. But in the ENTC, my life has been transformed upside down. It is a completely turnaround. So in ENTC, what I really love about the electronics and telecommunication engineering, especially when I'm focusing on higher studies, it has a very rich curriculum which focus on fundamentals. Because if you're focusing on higher studies, if you need to do cutting-edge research, you need to be good at fundamentals. In that sense, if you take about signal processing, telecommunications, probability, statistics, electronics, robotics and control, you name it, in all these areas, the curriculum itself contains a rich set of fundamentals, and it will give you very solid understanding on the fundamentals. Even though I am not heavily involved in electronics because that is not my passion, but I have a very good understanding on those areas as well, thanks to this curriculum. And also it helped me indirectly when I'm working with my current research area with networking and AI to adapt to the systems, because I know how underneath things operate as electronic systems or networking system, because it will give me that fundamental knowledge. And also it prepares a diverse range of opportunities, because that is one thing that I really admire about the ENTC, because if you take the look at the personalities, I think you have 2 good examples here, because Deepan is kind of completely different direction in robotics. I am completely different direction in telecommunications and AI. It will, if you take the 115 students who graduate from ENTC, including our the department BME as well, they have hundreds of journeys. So basically, you have a lot of wide spectrum of career paths that you can build based on the things that you learn from the ENTC department. And also, it will teach you the science behind engineering. I really put some weight on the word science, because engineering is not just a practice. because engineering is applying science to solve real-world problems. When you do research, actually, you have to learn the science behind engineering to build more contributions. Because I have authored over 4 IEEE journal papers, which mean that when you're writing a research paper or top-tier research paper, you have to contribute to the body of knowledge. So you have to contribute to the body of science. In that sense, in the field of the electronics and telecommunication engineering, it will give you that knowledge of the science behind engineering. And the other thing is, it has very unmatched student life with events such as Abhina. I think it is the most funny, I would say, most entertaining event in the university. And also we have competition like SLRC, Expos, and I think it is not a wrong statement to say ENTC is the one department that having the largest number of events in a calendar year. So that is one thing. And the other thing that I really admire and what is completely changed my life is I get always surrounded by top achievers. So if I will summarize my profile at the end, and also Deepan has summarized his profile nicely in his presentation. You might think, okay, these are exceptional profiles. But if you come to the ENTC, those are just the norm. So because everyone has those kind of achievements, and you always surround that kind of top achievers. So that naturally push you to achieve higher achievements and push you to the limits and make sure you achieve your top skills and you achieve your top abilities and make sure that you can get achievement on the world stage, because there are very big achievements with our graduates from our batches and also the student before us and also the current student as well. So those are the 5 key things. If someone asks me like give me the 4 positives of the ENTC, or what are the good things that you see that transform you inside the ENTC, those are the things that I can tell to my junior students. Yeah. So now I'd like to spend a bit about the life at ENTC, because I'm not much going into the technicalities, because as the previous speakers mentioned, is undergraduate life is not about just learning theories. It's about building a profile and building a life and building memories. So in that sense, we have Abhina, of course, as I mentioned, that is the most entertaining event of the year in the university, and everybody is waiting for it. If you haven't watched Abhina, so no matter which department that you select next, please make sure you watch Abhina in the next year. And also we have SLRC, that is where actually our Deepan has started this journey, and there are thousands of kids start the journey of robotics from the SLRC. Even myself has a very wonderful journey back in 2019, like students from my own school participated in the journey and get a very good score, and they actually select to the finals. So there is I would say one of the most socially impactful event that done by our department. Another thing is like the Expos. I think that is kind of a mini Expo exhibition. Actually, it is again very good socially impactful event that conducted by our department, because a lot of school kids coming in and it will transform their life because they get to know what are the technologies are. Some of you may be attended to it, and you might remember that how that changed your life and how you inspire to become an engineer at some day. So those are the events that our ENTC department, like kind of 3 major events. And during my life, actually, as Deepana mentioned, we are both batchmates. So basically, these are the kind of little bit of movements that we have in our life. So basically, the image that in the top right corner is our first batch trip, and the image in the bottom right corner is the last image that we taken as a batch in our batch photo day. And also the middle one, this image here is actually the Envoyage, and this is our SLRC event. I think it is in 2019, and this is the picture that we took actually just taken before that we going into the internships. And when we see these each and every faces, we can name the countries and universities they are in. Actually, they are all in a different part of the world now. Some are in Australia, some are in USA, some are in UK, and some are in USA, and some are living in Sri Lanka and doing very good at their jobs. So it is actually, I would say, we always like call this ENTC not a batch. We always call it as an ENTC family, because it's kind of one big family that who held up for each other. Because inside the department, these 4 years, like everyone is helping each other and everyone is caring for each other, and it's a kind of a journey as 101 people together. So it is pretty much a big family and pretty much big nice memories that you can collect during those 4 years. Yeah, so when we talk about the achievements of the ENTC students, and these are kind of the past few years that we can see. So basically, they are built in the international stage. They have won a lot of achievements, championships, first runner-ups, and the lot of international stage events, because these are the ones, especially if you're targeting at higher studies, these are the ones that give you an advantage over the other candidates. Because I am sitting in the graduate research board at the University of Technology Sydney, where I'm pursuing my PhD. So I know is how competitive the PhD opportunities are and how value these achievements can give you in the PhD admission process. So during a PhD, do not focus on just getting the good grades. Make sure you participate these kind of competitions or this kind of extracurricular activities to make sure you mark your name on the international stage. Because otherwise, what will happen if you just focus on your grades, you will get a good GPA, but at the end, you will only end up with a transcript. It is not going to work. And these are actually within 1 year, I think these are only the few. And if you go to the our ENTC homepage or Facebook page, you will see thousands of these images because, and if you talk any of these students, they will reflect to their own story, because I think if you need to know me, you can contact me, but I think I just need to share ENTC is a place that give you opportunity to go beyond the degree and build your portfolio at the international stage. So these are big examples, and also these are from some other examples that people have won, and also actually it is from our batch actually that have won actually the Signal Processing Cup back in 2021, and also in the same year actually our students won the VIP Cup as well at the same year, and also people have won the Risky Processor Challenges and the we won Manamperi Awards, and also people have won the some paper accepted at the very high venues as well. So there are a lot of research opportunities, because I'm not going to detail that much, but I need to tell you, if you come to the ENTC, that's the norm. If you think, when I'm looking at these images, if you're thinking, okay, this is extraordinary, this is a very big achievement, if you come to ENTC, this will become the norm. Because person sitting left to you have some achievement like this, and persons who are sitting right to you will have some of these achievements by the end of their degree. So that is the norm of the ENTC. That's why I say you will always be surrounded by great people, talented people, and the top performers. So that is the one thing that I need to give you from my side, because if you need to focus on higher studies in any field, you need to have this kind of presence inside the international stage. You need to have some sort of evidences inside your CV, evidences in your CV apart from your GPA to prove that you have the ability to compete in the international stage. Because if you take an undergrad degree or PhD, it's that you adding knowledge to the body of knowledge to the a whole human race. So you might be capable of performing at the top tier at the international stage. So ENTC is a perfect place for you to do that if you are interested in the electronics and telecommunication engineering. And also when it comes to the internships and job opportunities, because that is the question that most people ask about when selecting the departments and when taking about the higher studies. So if you are aiming for the higher studies, as an undergraduate, you can always focus on internship at foreign universities. I think in the last year, I think around 25 students from ENTC got the foreign internship. Even I got foreign internship opportunity at University of Manchester, as I remember, in UK. But unfortunately, due to the COVID, I didn't able to go. And but there are, I think, in every year, few people from our university going to these universities across the globe for their internship, and also the top tier companies for their internship. So there are pretty much big amount of companies. And also when it comes to the higher studies, there are a lot of students currently right now. I think each and every, I think more than 40 to 50 students going to the higher studies. Even our batch, I think just after graduation, I think Deepan and myself, and also a lot of people, like more than 30 people just finished within a couple of months and for the PhDs. And I think currently within our batch only, I think more than 50 people doing their PhDs in various countries. And some are in universities like Princeton, some are in University of Maryland, some are in Imperial College London, and some are in EPFL. One of my good friend, Charlotte, is actually in EPFL, and our Deepan is in ETH, and myself in UTS. And also I have a few more friends in the UTS as well. And the irony is actually I forgot to put the University of Sydney logo there. Actually, I have a couple of my roommates in Sydney also from ENTC department studying in the University of Sydney for their PhD. So there is a very big portfolio that you can get help from the alumni if you are willing to take the higher studies opportunities. Yeah. Now, will all those things explain that how you get the most out of your BSc degree, no matter which department you go, but I specifically focus on in general as a graduate who need to get most of your bachelor degree when you go into the university. First, you need to understand that bachelor degree is the place that you get to learn how to learn. Because bachelor degree isn't taught to anything. The only thing that it teaches you to how to learn. So it will make you a good learner. It will not make you that know something perfectly, but it will give you the ability to learn. The second thing is you get to learn the fundamentals of engineering discipline. Again, you might not be making an expert, but the degree will give you the fundamental knowledge. To become an expert, the job is in your hand. You have to do something on your own. You have to participate competition, you have to do research, and those are things that you need to do to make a profile and make an expert in a certain area within the field that you are choosing, no matter which department that you choose. And also, you will specialize in one area more than others. The more than others part is important because you still need to learn the other areas as well, but you will learn a bit more one area than the other area. So basically, that's why I call it, you will specialize in one area more than the others. And also, the degree, it's the proof that you are ready for the next step, but it will not a job, and it is not a designation, and it is not a guarantee that you are getting a job or PhD or for anything. It will just tell you are ready for a job or PhD or higher studies opportunity. But to make it work, you need some extra qualifications. And also, your profile is shaped less by the name of your degree. The degree is just a one line in your CV, but it will shape more by the experiences, projects, and the achievements that you gain while earning it. So that's why I always show that accomplishment that students have been made, the student life and everything. The thing that make you capable enough to get a good job or a PhD offer or high studies opportunity, it's the experiences, projects, and achievements you gain while you are an undergrad. Having said that, the best example that I can give you some reflecting from my journey. So far, actually, I have first published 4 Q1 IEEE journal papers at top Taiwan as a first author. And first Q1 journal paper was actually published as an undergraduate. It was my undergraduate research project because the ENTC curriculum offers you to do a research project at the final year for 5 credits, and you can take that, and the final year you can actually do a cutting-edge research and publish in a top-tier journal if you work hard on it. And also as an undergraduate, actually, I was won the 2nd place in the Asia Pacific region at the IEEE ComSoc Internet for All competition. And this competition is actually an open competition for all people. The universities, ISPs, and companies are participating, and I participate as an individual undergraduate student, and I still end up getting the 2nd place at the Asia Pacific region. And also, as I remember, this is the first ever international recognition that is won by an undergraduate student in Sri Lanka in the IEEE ComSoc sector, ComSoc student branch, not from the other areas, but in the ComSoc, this was the first one. And also, immediately after graduating, I worked in 2 Silicon Valley startups as a machine learning engineer, namely Analog Inference and Simplify Incorporation in the California, USA. And before coming to the PhD in my full scholarship PhD with the full scholarship at UTS. So this is my journey so far. So as I mentioned, like if you look at the higher studies and if you aiming to get into the higher studies, or if you aiming to get a PhD opportunity, do not focus just on your grade, focus on building a profile. So if you're interested more and if you need to talk about more, just scan this QR code and contact me in LinkedIn. Actually, I intentionally put my LinkedIn profile on it because I just need to give you some professional experience in that as well, because I'm thinking of putting my email, but then I realized if I put my LinkedIn profile there, you have to make a LinkedIn profile if I need to put a contact me, because that is a good opportunity for you to make a LinkedIn profile at this stage, because it will really help you to build out your professional network, and it will really certainly help you when you looking for a jobs or looking for higher studies opportunity. Because at the end of the day, no matter how capable you are, no matter how talented you are, if the interviewer or selection committee doesn't know you well, you will have a less chance. But if you know the people and if you know the connections, then you have a more chance at your professional stage. It can be a good job, it can be a higher studies opportunity, it can be a PhD offer, but network is the profound important thing. So that's about my journey, and I wish you all the best on your future journeys. And I hope you all can make a good decision on your life based on your passion and based on your based on your skill sets and the based on your life goals. And I wish you best of luck with all of that. Thank you.
Thank you, Mr. Soboshan. And yes, it is now the time for questions and answers. So if you have any questions, you can unmute yourself and you can ask the question, or you can drop text in the chat. So this is your time to do that now.
Yeah, so I think I have like 4 chats in the chat. So one student is asking what is the difference between BME and ENTC. So actually, I think during our days, my answer may be not fully correct. So basically, the difference between the BME and ENTC curriculum are mostly in telecommunication subjects. I think they replace some sort of telecommunication subjects with the biomedical subjects, as I know, but please double check on that because I'm not pretty much sure about it. But in the electronics side and the signal processing side, most of the subjects are same. So, but the difference coming in the telecommunication subjects, as I know, but please double check on that one. And if you need to get to know more, please reach out to me and I will direct you to the corresponding good person who know the difference between those two fields. Can we get into chip designing or related field by going ENTC? Definitely. I know I think there are a few people who currently studying PhDs in that area from ENTC in the universities in USA. I think one name I remember is Kipin Vikramasinghe. If you can search in LinkedIn, you can just contact him via the LinkedIn. And also, if you need to get to know more, just reach out to me and I will direct you to the correct persons. There's another question. What's the best department to pursue if you are interested in robotics? I think as Deepana mentioned, it's ENTC. So that for robotics, if you're interested in robotics, I think it is a pretty much good choice. But it depends on what robotics that you need to do, because there are some robotics field, there may be some other departments are good at, but just look at like what is the exact thing that you need to do, because certainly there are some subfields in mechanical engineering and also in electrical engineering as well. There are people doing different sort of robotics, so it depends on which subfield of robotics that you need to do. Are there companies for electronics product design in Sri Lanka? That's a tough question. There's a few, but if you look at outside Sri Lanka, there's a lot. So do not restrict into Sri Lanka only because you are selected to the topmost engineering school in Sri Lanka. So you should be able to compete at the world stage. So University of Marotta will prepare you for that. So do not restrict into Sri Lanka, even if though there are no industrial opportunities in Sri Lanka, you can always have opportunities in foreign countries. Can we get industrial experience in robotics while studying in degree in ETC? Do Sri Lankan companies accept uni students? Again, there are opportunities, but it depends on the kind of profile that you have and the CV you have, what is the project have you done. And also there are a lot of students who have foreign internships as well on those fields. So please feel free to reach out to our alumni on LinkedIn and they will let you know the most of the knowledges. And also I have one guy in my own department as well who doing the PhD in the robotics area. And there are a lot of my colleagues actually doing the higher studies in the that relevant field, and they may be able to offer you like mentoring sessions and so forth in those areas. Can electrical engineers also do ENTC jobs? That's a tough question. My answer is probably yes, because bachelor degrees just give you some basic knowledge. If you're willing to learn the extra stuff, you can always do those things. I haven't enough GPA for ENTC, but I like robotics side. Are we studying robotics in CSC? That's a tough question. Actually, I have not much idea about it. It may be good to ask some CSC person about that. Is game development side related to TNTC? I don't think so. You have to check with probably with CSC if you like on that one. Yeah, so I think I will to other students, I will just reply in the chat, but I think I see like a lot of messages are coming in. I will just say a little, and I think I will hand over the next speaker, and then I can keep on the chat in the Zoom. So moderator, I think over to you. I will like keep the discussions offline. Thank you.
Okay. Thank you, Mr. Salushan, and thank you, ENTC resource persons, for that inspiring session. And now, to begin the MSc segment with an industry perspective, please welcome Mr. Tanuj Shamil. Mr. Tanuj is a University of Monroe MSc graduate, currently working as a process development engineer at Ceylon Taylor's Tea.
Hello everyone, can you see me?
Yes, sir.
Yeah, okay. Let me share my screen. Okay. Okay, basically I will start with a quote that we have used in a lot of field familiarization sessions in the past, which was a post by Elon Musk in X, which is previously known by Twitter. The post says that take material science 101 and you won't regret it. And he also replies and take astronomy too. Obviously, he's coming from the perspective of a CEO and entrepreneur who is doing space explorations and electronic vehicles and stuff. But the idea still stays the same. So before I dive into like specifically into material science engineering and what I do here and how you guys can move up the career ladder, as well as if you want to go to the academic side of things as well. So here is some photos like that while I was working here. So I'm working at Ceylon Taylor's Tea, a tea factory that is currently under recommissioning to basically the tea science in Sri Lanka usually is not backed by a lot of sciences, it is mostly based on how the traditional tea making works and how traditional tea makers, the people who actually regulate and not regulate per se, operate the process and adjust parameters based on them. But in here, as process development engineer, my goal is to like remove those traditional paths. Like for example, if we take like rubber industry, it is very industrialized and it is very research backed. But the industry is not currently moving in that direction, and it was stagnated for like some decades. So in here we are trying to change that. We recently hired some people as well, so that's what we are doing here. So let's see how it goes. So to go into material science first, there are a lot of people like saying that we need to do certain things, and I like let's say electronic, I like computer, and I should I go to that department, and I have this kind of a dream, and what should I do in field selections, those kind of things. So I would rather give you a different view, like point of view to look into this problem. So basically you are first year students now trying to select a field to pursue for next 3.5 years. So which become a crucial decision as you move with the field. So if we think about the engineer, not engineer per se, even though the slide says so, let's say think about any person, there are a few people that usually can do a lot of things. So for example, we know experts, right? So experts means like usually I-shaped. So basically, if you look at this diagram, the depth is in the downward direction, and the horizontal direction is the breadth. That means how much you know, so how much fields you know, and the depth is how deep you can go through in a specific field. So if you think about some kind of expert, for example, let's say if you think about someone who took PhD in, let's say, silicon wafer manufacturing using some economical method, he might be an expert in that specific area. But if we ask them how to do heat exchanger calculation, he might be not be able. Means you have a lot of breadth, and you mean of fields, and you know some kind of a specific thing to a depth to an expert. So that is very valuable in industrial settings. For example, if we are hiring a software engineer, let's say, we need to know what kind of things that he can do. For example, software engineer might not be assigned to a specific project. He need to know a lot of things about computer science as well. So usually I-shape individuals are usually consulted to the what do you call compensate for other employees. For example, there is an employee who know microcontroller programming in our company. Then we need to hire somehow or consult an expert who specifically know about a specific kind of a chip, how to do it. So those are kind of thing. Those are the two people that we will work with. And there is some kind of a somewhat advanced person called M-shape. M-shape mean like you have a lot of breadth as well as you have multiple what do you call expertise in a lot of field. For example, for mine, if I take me as my as example, uh, when I select material science engineering, I had this opportunity to go electronic engineering, CS or anything like that. I had like I think 4.1 or something like GPA. But I specifically chose to do material science because material science is inherently designed to make you like a T shape, like you have a lot of breadth because material science and engineering is a multidisciplinary field. So usually you can't do anything alone. You are just the bridge between how actual manufacturing process happen and then how the industry bridge between how each industry needs a specific thing. For example, if you say there is a machine designed by a mechanical engineer, you have to select material and characterize material and do certain things and actually realize that design into a tangible thing, right? So to do that, you need like usually material science engineer. So basically, we bridge the between different fields to a real world. So that is our actual role. So for example, if you go to the material science engineering department, you will usually hear the word. We are a multidisciplinary field, not scoped into one. So in that sense, we will learn. Even though we know a lot of things, like even though we don't go that much to depth in a lot of fields, but we go very in depth up to quantum level regarding materials like actual physics, chemistry, how certain things interact with each other, how matter and light interact with each other, how electron inside a silicon chip can pass the p-n junction, and how we can control it based on the voltage, how we can give multiple level voltage levels and things like that. So basically we go very deep into up to quantum level as well. So that is our expertise, but we know how a microcontroller works, how some circuit works, because we don't go as depth as a electrical engineer, obviously, because electrical engineer or electronic engineer, because it's not our expertise. But usually we learn how ML works and stuff like that. There are interdisciplinary courses that we study when we come to materials science engineering. So so that's the thing. So when you go to the industry, I'm talking about materials science department actually. There's an engineer who usually when failure occurs, let's say machine is broken down and you have to investigate what is the cause of it. So usually those root cause analysis and how certain real world phenomena happen and how we can explain it using science and engineering. So our department name is material science and engineering. So basically we delve into science as well. So and you can so basically you can inspect that machine and try to come up with solution, and a lot of things about like there is a fatigue stress kind of thing, and there are materials that is suspected to that, and like how corrosion happens and maybe how environment condition affect that machine, and you have like very large breadth of knowledge. Then you will try to utilize it and when you investigate in it, you feel like I need some kind of expertise in mechanical engineering because I know this much of depth, but I need some on expertise. So you usually use in the T-shape, you find out what kind of areas that we need to investigate. Then you will hire experts into them, and you will actually eventually make a M-shape like system where T-shape is you, and you will fill in experts to go to the depth. Or you can just become M kind of person in selected field. So basically, when I selected material science and engineering, my goal was to become a software engineer actually. And I love physics as well because my family didn't allow me to go to a physical science degree, and I had to go for engineering degree. I chose the closest into the physics and actual sciences. Chose material science and engineering. Then I followed my passion of software engineering, and like 4 months before graduation, I got a degree in software, not degree, like job in software industry in a reputable company. Then I worked for like 1.5 years. Now I am working in the manufacturing industry, doing research and development, as well as managing people as well. So I purposefully chose to be expert in two different things actually, and that seat I have on. So I'm saying, and you guys to be motivated and informed about like how you can move forward in a ladder if you everything. So, so basically, this is the summary I want to give you. I type is expert, who is a specialist. T is a character who is have a depth as well as some kind of depth, and multiply the M type is has lot of area, like few areas, handful of areas with expertise as well as lot of breadth. So M times, so basically when you working in the industry as well as corporate structure or in general in real world, you need a system that act as a M type system. But the problem is there is no lot of there are no there isn't much of M type people. So we what we do is usually find T kind of people and connect with them I kind of people and try to make a M type of archetype in our industry. But if you can become M type person, you will have a lot of opportunities and go beyond what is seems possible for a just degree. So this is just basically what are the things I've been explained up to this point. And when it comes to material science and how it fits, material is in fact defined to be T-shaped. That what I call it is a multidisciplinary field. So what in material science and engineering, what we do is when we consider a material, there is a structure to that material, and there is a inherent properties of that material like friction friction of coefficient, like tensile strength, like physical properties that the material have, and also performance, how material is performant, like for example what kind of a value we get per kilogram of this, or maybe unit what do you call maybe for $1,000 how much like performance we get in strength or something like that. So those there are few things that is connecting material science. So basically what we do in material science is what happens to processing performance and properties when we change the structure of the material. How the other three changes when we change the properties of the material. So basically what we do is try to manipulate certain things and get desired result to our requirement. So we always have to juggle between lot of things, like sometimes if we analyzing a material, we think about the strength and things like that, and we decide a material, but there are an issue of that material that it is electrically conductive and it is not suitable for that specific application. So we have to know a lot of things like how electricity works, how microcontrollers work. So that is a thing that we have to do. So it makes you a T-shaped usually, very breathful, and also science and material kind of thing. Too like too much, not too much, like become you expert in material. So everything you see around you is material. So you have to actually know material science to how to manufacture it, how to manipulate it to our own desires and things like that. And so uh, in material science we think about solid mechanics, chemistries and thermodynamics, material characterizations, processing and manufacturing, designing products and things like that as well. And uh, so also simulations and failure analysis and forensics and sustainability kind of things and quality standard and regulation, how to comply a certain company with ISO and ASTM like quality standards low. You have a lot of on your plate, and you can pick and choose what your flavor is. So at the end of the day, actually you will build your own role. For example, process development engineer in this company, the role that I am currently working in, is not existed before in this company. So when I came to this, the with the things I do inside the company, the role is kind of like tailored towards my skill set. So that is the one advantage being a material science engineer. So if you learn something like software engineer like me, you will have that kind of experience also. So for example, in here usually the microcontrollers and for process automation usually the process also automation usually in the field of mechanical engineering and stuff. So but with the knowledge I have with programming and microcontrollers and PLC, how it works, I have ability to like even investigate in those areas as well. So my goal is you to guys to like decide what you want to be. Would you want to be expert, or would you be a T-shaped individual, or maybe a M-type individual? That's up to you. So if you want to be a I-type individual and expert, you pick a field other than material science, because material science is not designed to be I-shaped, and you actually go very depth on that and do PhDs and go abroad and do certain things. And if you want to be T-shaped, you can do material science just fine without doing any fancy things, and you will end up being T-shaped. And I think, as I can remember, the last batch of our department, our batch, I mean, our batch, which is 2024 batch. 2024 means like graduation year. So we are 19th batch in University of Morato. I think we are 10 or 12 people who is already working abroad out of 50 people that we have. So like a 10, 20 to 15 to 20% of our students in material science engineering is doing PhDs and masters in abroad as well. So, and there are a lot of things that we can do with material science. I choose material science because I have the freedom to choose for myself, even though I change my mind later. So that is how I became material science engineer as well as software engineer as well, and working in multiple things and understanding how nature works. So it is very fun thing to do and very fulfilling at the moment, that you get to decide what your role is in the grand scheme of things, right? So yeah, that is the things I want to tell you guys. I just don't want you to guys like uh, basically the main idea should be like I should encourage you to come to material science department, right? That is the main goal of this field familiarization session. But I think you should decide for yourself what is your archetype. I mean, what kind of person you want to be, and using that decide what you want to go for. And I think things will eventually work out. You don't have to do much like, I'm not saying you don't have to do hard work, but you don't have to like grab onto things and pursue things very like materialistic way. You can like do what you love and achieve what you already love, and get paid handsomely for them, and maybe live in the countryside with cool sceneries to watch and cool walks to go around. And yeah, so I think you will be just fine. Choose wisely. Just have a conversation with you what you want to be, and decide if you want to go software engineering or electrical engineering or maybe electronic engineering, mechanical. Go for them. Go for them. And if you want to be someone who can do a lot of things, come to material science, and you will have solid foundation of going there. So I think that's about it. If you have any questions, reach out to me. You can by WhatsApp or email. Don't call actually, because I get a lot of calls per day. I wouldn't be able to answer any of them. Just drop a WhatsApp message or just send me an email. I will get back to you. Any question if you have. And yeah, that's about it. Yeah, if you have any questions, you can ask. I will stop sharing screen. Yeah. Oh, yes.
Guys, if you have any questions, you can drop them in the chat, or you can unmute and you can ask it yourself.
Okay, you guys contact me through my WhatsApp or email. I will get back to you. I think we have another case. So hope you guys make a good decision and go for what you love. And maybe see you around. If you see me someday and you remember me, just come and talk. And yeah, see you guys.
Okay, thank you, Mr. Tanuj. Next, to discuss advanced research and bioengineering pathways, I would like to introduce Dr. Isuru Karnaratna. Dr. Isuru is the head of bioengineering at Midiras Novohat. He earned his PhD in mechanical engineering from the Hong Kong University of Science and Technology, specializing in MEMS, and holds a patent for his medical sensor innovations. Dr. Isuru, the floor is yours.
Well, thanks everyone. Am I audible?
Yes, sir.
Perfect. Let me share the screen. I think you can, sorry, I think you can see my screen, right?
Yes, sir.
Yeah, thanks, Dan. Well, thanks for the introduction, the kind introduction. Yeah, I'm Isuru. I work as a senior scientist and head of bioengineering at Novohat. If you want to add me in LinkedIn, you can add me, and then also any questions you have, you can forward it through that or any other means if you can contact me. So I'll take a bit of a different approach to compare, yeah, kind of a different approach, although I should be, talking about material science. Let me walk you guys through an industrial, like from design to a clinical level, like a real world application of a project from top to bottom, right? So you can decide for yourself, you can judge for yourself what you will need in this kind of a journey. And hopefully you will learn something as well. You might have heard of glaucoma. This is an eye disease. It is characterized from, well, it's not characterized. It's one of the characteristics of glaucoma is high eye pressure. We call it intraocular pressure. If I just say some of the things, like the vision loss caused by glaucoma is irreversible. For example, the first leading cause for blindness is cataracts. It should be quite familiar with you, and then it's reversible. You can remove the cataract and you gain the vision back, right? But in this case, there's no chance. If you lose anything, that's it. You'll live until you die with that vision, and that's it. There's no cure. You can just manage it, stop the progression. That's how difficult this can be. So currently in medical clinics, how they diagnose glaucoma is by checking your pressure. But some of the types of glaucoma, you don't really have any high IOP, high intraocular pressure at all. So you might lose your vision without them noticing. And at the same time, in like anything, like your blood pressure, like even the eye pressure, the IOP is also a circadian rhythm. It's a function of time. It changes. And the doctors have found that it maximizes at night, and then there's no chance of them to understand what's your maximum pressure in the eye is. So that problem is being researched, like people, like scientists all over the world, they're trying to find a solution for this using sensors, obviously, and trying to find what the maximum IOP is and how each person's IOP is changing through the day. And they try to use that to prognose glaucoma. That means like not diagnose. Diagnose means you have something, you have some symptoms. Actually, diagnose, I mean, there's no symptoms in glaucoma. If you have some vision loss, then you go back and see, oh, you have glaucoma. And then you take medication to stop it. But we are trying to solve it as a prognosis. Like we have healthy people being tested, and then we try to predict that is there a chance that this person, the specific person, develop glaucoma in the future. So that's the idea. So to overcome these limitations, one of the companies have come up with a contact lens to measure eye pressure continuously. It's a wireless sensor. It tries to track the intraocular pressure continuously and draw a continuous line, continuous pressure line. They have some difficulties like connecting real millimeters mercury, like real pressure values to the their sensor output. Now they have some I read that they have now some developments, but we also tried to solve this. The approach we got is LC sensors. So I'm sure like the electronics graduates who just presented should have some idea of this already. And you might have, I mean, even of course, the electrical engineers are here as well. So LC sensors are very special because they don't use any kind of, it doesn't need a battery. You can have a sensor, a wireless sensor without a battery. That means it has its cons, it has some disadvantages as well, but it can be used in like very harsh and sealed environments. For example, in a glass bottle, it has high temperature and high pressure. You can place an LC sensor inside that and measure the temperature, the pressure, the humidity, you name it, with an LC resonator, and the reader is outside reading it. So this kind of an interesting technology. So we try to use this to solve the problem I just showed you. The idea is that like we embed this sensor in contact lens, and then we wear it. And when the pressure changes, the eyeball dimensions change, and then the size of the inductor. So in this idea, you can see the sensor is the frequency. There's this frequency. I'm not going to go into details, but there are two parameters that can change easily in most of the LC resonators. We are looking at the change in inductance or change in capacitance. So in our case, we were looking at change in inductance. So we needed a fixed capacitance and then a changing inductance. That's what we aimed for. You can see we are reading it currently. I mean, in this version, in the prototype, we were using a network analyzer to read the signal. And then we did the prototype like that. So that's the idea. So this is the technology. And the next step is a sensor fabrication. So you can see this is one of the sensors we made. Like we made two types, basically. Like we went in two parts, and then end of the day, like we picked one and then went for the clinical trials. So you can see in this one, we had to create this with we needed an inductor, we needed a capacitor. So all of this, it's not like you go to a shop and then just buy a capacitor and connect it. I'm talking about a contact lens which is less than 200 microns thick. It's 0.2 millimeters thick, right? And it's flexible. And then this sensor has to be even thinner. For example, it has to be less than 100 microns because you have to encapsulate it with proper materials such that it does not be toxic. For example, you're wearing it in your eye, and then eye has tears, right? So if any like hazardous chemicals leach out from these sensors and everything, and it gets your blood and infect your eye, you're done. Your company is closed. That's it. End of the story, right? So each and every step for this sensor fabrication, I'll go through very quickly. So the conductor material was I mean, it's obvious, like, to select copper because copper is the most like readily available and used conductive material in the world, actually. So we did use that, of course, for the prototypes, but we had other choices as well. I mean, for example, gold, we could use gold. That's easy. And the thing about gold is that it's you have to use like very harsh chemicals to etch gold to have an inductor. So we did the prototyping in copper, and then we could think of like encapsulating everything to make it biocompatible. That's the idea, right? So yeah, that's it. Inductor is done. And then the dielectric material, like mostly dielectric materials are chosen from polymers because of the high the strong dielectric constant, and then the breakdown is high. So for this, and also in this case, it was the biocompatibility also mattered. We chose polyimide. We tried PDMS, we tried polyethylene, and we ended up using polyimide as the dielectric material for the capacitor. And then we had a nice frequency with polyimide because out of all the materials we used, the highest dielectric constant was in Pi, and also it has a very high temperature, like stability, chemical stability as well, so it does not react. It's like almost inert. So that's the way to go for the dielectric material. And then maintaining the thickness and flexibility was a huge challenge. Like we had to finish the sensor within 100. Luckily, we could end up within 40 microns end of the day. So the copper thickness was like 15 microns, and then likewise. And then we did consider other options as well, like flexible conductors, flexible dielectrics. But end of the day, I did tell you that we were looking at a changing inductor and then a fixed capacitor. If we had flexible everything will be changing and it will be a mess. So we chose to go in the thinner way and then this way. So the fabrication method is photolithography. Well, our colleagues from the electronics department, they did mention that about the IC design as well. So we have something to say about the IC design as well. Photolithography is the method used for IC fabrication, like even PCB fabrication. Simply put, it's based on photolithography. So we used well, I was doing this in a nano fabrication facility with all the, well, for example, the next desk to me, they were doing ICs and I'm doing this. Like what I was doing is really not like in nano level, like not even in micro level. It is in micro level. Like it is in the features of the inductors and capacitors were in the micro region, like micro scale. So we use that to etch the sensors and for the real value, like, and to get the properties to that level, like the dimensions to that level, and then we ended up having the sensor fabricated. Once the sensor is fabricated, you can see two designs, as I said, right? So we have this design over here and another design. We ended up using this for some I'll tell you what the reason is. But when we selected the sensor, when the sensor is done, you have the sensor working, and then the next question is that I have to wear the sensor for 24 hours. That's the idea. That's why I made it, right? So the cornea in the eye has no blood vessels. It gets all the oxygen from the air, right? You can't just wear a like fully sealed contact lens for 24 hours and then your cornea will not have sufficient sufficient oxygen supply and it will die. So we had to like focus on this matter. So we did go for a flexible, transparent material, which is, you might know, PDMS. It's used everywhere in microfluidics and you name it. Like it's biocompatible. You can basically eat it without no poisoning, nothing. So we used this material and we made all the molds, and then we ended up having a lens with less than 150 microns, right? So with that, we did go we could achieve, like the flexibility and the tolerability we wanted. The next question was, PDMS was fully hydrophobic, like water will beat it like a lotus leaf on PDMS. So we had to go through like functionalization of the surface, like we did some oxygen plasma treating, and then we introduced some functional polymers, functional groups to make it hydrophilic, that basically wets. And then the optical properties and clarity was based on the mold design, which we did ourselves. And then we got the mirror kind of finishing. We tested different kind of molding materials, and then we ended up using acrylic, like PMMA, polymethyl methacrylate. And then we ended up making a good lens that can be worn on human. And then we tested on rabbits, we tested on, before, like different platforms, and end of the day in clinical trials. So we ended up creating good results. Like we tested it on like healthy subjects, patients, and I have many more other publications to show that the good results we got. So I'm not going to go into details of those. So you can see how a materials science kind of background can lead you to this kind of a project, like from the beginning, from the design. Like most of our colleagues said today, like it's not going to be just one science. You can't just survive like with the eye approach in this kind of a project, like Tanu said. So it has to be multidisciplinary, even though you might have a team of like a programmer and someone from physics for the development, but you have to have some kind of idea of all the things to do, like to lead this kind of project, right? And also I should say that you have to have more and more tools, like maybe some programming language, and then maybe some ability to make some PCBs, and then get something fabricated, for example, some analog kind of IC, also microcontrollers. And then well, you name it, you will have some time to spend in different kind of fields in the upcoming couple of years, and then make sure that you have many more tools in your toolkit. Otherwise, if you only have a hammer, you will see all the problems as nails, but it's not the case. So it's not going to work for definitely not going to work for in the industry, and you'll be isolated. So just make sure, regardless of the field you're picking, just make sure you have many tools in your kit, and make sure that you're a problem solver. That's the best way to go up in the ladder, in the corporate ladder. When you prove yourselves to the people, like when the managers know if you get something to do and you get it done, and that's it, the next problem and the next, you will solve it yourself, so you can climb up the ladder. And also the communication problem is huge, I would say. It's not like communicating, it's not just communicating between the teams. You have to communicate what you did, for example, with publications, with presentations and everything. So you have to take care of that as well. Well, all this project was conducted in this university I graduated from. It's from HKUST. And make sure, I should say that in a university, you have a lot of years, and then don't just do learning. You have a lot of other things to do. Make sure you enjoy your life and take the maximum out of that. So I'm going to end my presentation here. I think maybe a couple of minutes more, and then I'll accept any questions you have, like about any higher education opportunities from material science, and then anything else. Thank you very much. Okay, Tamir has reminded me that because of the time limit, there will be no Q&A session. Well, thanks for that. But just a note that the the first department took like 38 minutes, and the second department 44 minutes, and then yeah, unfortunately, the other departments are going to have not that much of time. Just also the punctuality is a very important aspect of engineering. So just make sure you develop that as well. Thank you.
Okay, thank you, Dr. Isuru. And thank you for MSc speakers. Thank you for MSc speakers for breaking down such a versatile discipline. And now we come to our final department for the evening, which is the Department of Mechanical Engineering. So to start off by sharing insights on higher education, top-tier academic research, and global opportunities, it is my privilege to invite Mr. Prabhatia Herath. Mr. Prabhatia has the most outstanding graduate of University of Mortua in 2023 with a 4.09/4.2 GPA and is currently a PhD candidate at Cornell University, researching vehicle dynamics and low-carbon mobility. Mr. Prabhatia, over to you.
All right, I hope you can hear me. I'll share my
Yes, sir.
screen. Okay. Okay, I hope my screen is visible.
Yes, sir.
Okay, so all right, so we had I joined a few minutes ago and I heard a few speakers speaking, and I've learned a few things myself as well. So the goal of my talk today would not be to delve specifically into one area of research or other my research, but give you a broader view of the possibilities of research pathways within mechanical engineering broadly. So I hope that would be more beneficial to you guys when deciding to choose a field at this stage. So to start off, thank you for the introduction that was given. And to add a bit more, I am from the 18 batch. I did from the mechanical engineering department. I was a lecturer for a year or so, and then I started my PhD here at Cornell University. Okay, and also I want to say that I was also in your shoes at quite some time back, wondering what department to choose. I also had the opportunity to choose any field I wanted to with the GPA I had. The reason I chose mechanical engineering was the fact that mechanical engineering appealed to me in such a way that others did not. The reason being that I'd say it's a fundamental field of engineering, like many other fields as well, and it gives you a lens to look at a problem in a very fundamental sort of way, whether it be a car or a plane or whatever, how it works and what gets it moving. That kind of approach, that kind of problems you can look at through learning mechanical engineering. And it's not really a black box approach. That was something that I did not specifically like, the black box approach, but rather to remove the box and go inside the box and see what's actually happening was what I wanted to do. And mechanical engineering is, I think, a field that really allows you to do that. So to start off, right, so I want to run through the main pillars that I'd say are inside the mechanical engineering degree program at University of Moratuwa. So mainly we have mechanics and design, thermal and fluid systems, manufacturing materials, robotics and intelligent systems, also systems, data and optimization. So if you look at the syllabus, the curriculum, which should be available online to you guys, you can see modules related to all these core pillars that are included in your curriculum. So we have inside mechanics and design, you have structures, machine design, dynamics, and then you have thermodynamics, heat transfer, fluid mechanics, and energy systems inside the thermal and fluid systems pillar. Inside the manufacturing and materials pillar, you have manufacturing, computer-aided design, computer-aided manufacturing, and also materials engineering. the stressors, strains, and how we analyze those. Then you have, we do also have robotics and intelligent systems. We have the mechatronics stream, which is currently a stream that you can choose along with 2 other streams, aeronautical and also the mechanical engineering stream. Then inside that, you have control, automation, robotics that you can delve more deeply into. Then we have industrial engineering, systems engineering. These are ways that you look at problems kind of holistically and apply it to industrial settings like a factory floor, for example. And then we also have some operations research which help us to make these processes more efficient, optimize them in a more mathematical sense. So you do have, if you go into mechanical engineering, you have modules and projects related to all these pillars that you can work on. And a good mechanical engineer should have a foundation built up on top of these pillars, and that would then allow you to do or delve more deeply into a lot of modern research areas. All right. So I've compiled a list of some research areas that I could think of, and I know people working on after doing mechanical engineering or when doing mechanical engineering. This is in no way a comprehensive list of or exhaustive list of what you can do in mechanical engineering. It's very broad than this, but looking at a few, we have mechanics, materials, and structures. We have people working on smart materials, composites, structural dynamics. So these are all modern research areas that people are working on. We have under the thermal, fluid, and energy systems, which is another core area that I told you earlier. We have current modern research like renewable energy, batteries, and hydrogen combustion, hydrogen fuel cells, fluid dynamics, and heat transfer. These are core areas that a lot of modern research is built upon. And then robotics, autonomous systems. We have under that, we have perception, motion planning, control, human-robot interactions. Then design and manufacturing, which is another core research area in mechanical engineering. We have modern technologies like additive manufacturing, digital twins, which are digital or virtual prototypes of industries or power plant or manufacturing plants that are built up virtually. Industry 4.0, which is sort of the 4th industrial revolution, with smart manufacturing and all these things integrated, and optimizing design workflows and things like that. Then, of course, you have computational modeling, doing a lot of simulations, mainly with CFD, computational fluid dynamics, and finite element analysis. So these allow you to solve complex problems that you can't really solve by manually using equations. Then you have the field of bioengineering and human health. We have, again, at Morotu also, we have a huge team of biomedical engineering people working inside the mechanical engineering department, working on biomechanics, medical devices, soft robotics, and wearables. That is also a big area inside mechanical engineering. And you have micro and nanotechnologies, micro electromechanical systems, or MEMS, small sensors with small, even small actuators you find inside everyday objects like a vehicle, for example. Nanotechnology and microfluidics, looking at things at the micro and nano level. So that is also something, a research area inside the mechanical umbrella, I'd say. And you, of course, have aerospace and transportation. You have automotive technologies, aviation, from commercial aircrafts to fighter aircrafts, for example, space systems, defense systems, and all these. So, so it's a very broad, as you can see, it's very broad. And that is one characteristic of mechanical engineering, I'd say, the fact that it's very, very broad and gives you a large choice inside the field as well that you can go into. And you will also see that some of these areas or some of these keywords might overlap with things the other speakers before me would have said. So that is in fact the case. And if you look at modern research, I want to highlight the fact that it is very, very interdisciplinary. So when you come to research, particularly the research pathway that I was asked to talk about, you don't look at it in terms of which field does this fall into, but you just look at what the problem is and how you solve the problem, and then what expertise areas do I want. So you then learn. So for example, and also I'd say the curriculum of mechanical engineering and most of the other disciplines at Moratuwa are designed in a way that you get flavors or you get some foundation in everything. For example, even in the mechanical curriculum, you'd see that you have modules, in fact, a series of modules in electronics and electrical engineering, mathematics, and all these stuff. So these would give you the tools to look at any problem, and then which you can build upon later. So for example, if you're going into research and deal with a problem that requires electronics for you to work with some sensors, then you go and build that skill as you go. So that is the nature of research, and I'm sure most of the other speakers were also touching on this earlier. So what you decide now, so if you decide to do mechanical engineering, for example, that does not mean you can never work on programming, for example. You will definitely be doing some programming. And in fact, there are some modules inside the mechanical department. You can learn programming as well, but you will have to learn more on your own, and you will be doing that when you delve into the actual project, whether it be in the industry or the research field. And this requires a lot of collaboration. Solving or giving an impactful solution to a problem would require collaborations across multiple disciplines. For example, let's say we have a car or autonomous car, for example. We obviously have mechanical engineers. We would have electrical engineers. We would have electronics engineers. We would have computer scientists, materials engineers. So all these disciplines would come together to solve a complex problem like autonomous vehicle. And the other thing I want to touch is that there are a wide array of computational tools, simulations, and also AI transforming how engineers look at problems, analyze, and innovate. So one advice I want to give you is get your hands dirty with these all these modern technologies, modern tools that you have access to. And those would define what sort of problems or allow you to do more in the problems that you choose to solve. And the other thing is lifelong learning that I want to highlight. So these tools, or whether it be what you learn through mechanical, if you choose to do mechanical engineering, what you learn through the syllabus, these things are continuously evolving like everything in the world today. So you have to be updated. It's a lifelong learning process. So be prepared to keep learning throughout, whether you go to the industry, or of course you'll have to be learning when you go into the research field anyway as well. And so I want to highlight that strong engineering fundamentals should remain the foundation. And these tools, whether it be AI, whether it be a simulation software, they should just enhance your ability and give you the data and other things for your engineering judgment. But at the core, you should have the foundations, the foundation built. And that is what you should do during your 4 years at the university. All right, so, okay, so since I was asked to talk about the higher studies pathway, I'll briefly go into what the pathways are. And all right, so the basic pathways, as you know, are you could do a master's, and then there's also a PhD option. A master's is usually a more in-depth specialization of a field, I'd say. And I've seen a lot of people use a master's degree as a point for transitioning into another career. For example, if you want to go into coding or computer science after mechanical engineering. So there are jobs related to mechanical engineering that require coding. For example, I know some people working on simulation softwares for mechanical engineering. So that would require mechanical knowledge, fundamental mechanical knowledge, plus good foundation in software engineering as well. So you could top up your mechanical engineering degree with a master's in computer science, say, and then you would have the flavors of both. So a master's would be opportunity for that as well. And so there are industrial masters, and there are also masters by research, where you do that master's as an entry point into research. A PhD is, of course, something where you do original research and you create new knowledge, actually. You add to the existing knowledge base, whether it be not in large amounts, but in very small amounts. The goal of a PhD, I'd say, is to create new knowledge. Can be a very small amount of new knowledge, but that would be the goal of a PhD at the end of the 4 or 5 years. And it's usually funded, so it gets quite competitive to get in. So you need a good academic standing and other things to get into a PhD. And it is usually the pathway into academia, R&D, and also other laboratories that do R&D, whether it be in the industry, the federal level, or any other research laboratory. So at this stage, what you could do is to build strong fundamentals, learn to use modern tools, whether it be software, whether it be how you use AI. So I mentioned AI a few times. So mechanical engineers, by design, I don't think learn the theory behind AI, but rather use AI as a tool, I'd say. So that is the case with most things, right? So we have softwares, for example, we have word processors like Microsoft Word. We use them to make our lives easier and do better things. AI for mechanical engineers would have a similar role. It's a tool, I'd say. So you have to learn how to use these tools effectively. And these 3.5, 4 years ahead would be a very good time for you to do that. And if you don't take anything else from this presentation, the next thing I'm going to say, go beyond coursework, is the main advice that I want to give you guys at this stage, whether it be academia. So I just don't limit yourself to the subjects that you're taught and the projects that you are required to do. Go beyond that. And the mechanical engineering department does offer, and even all the other departments, I'm sure, would offer many projects outside the curriculum requirements that you can get into. And the mechanical department, of course, you should know, does have the Formula Student project, which you can also get into. And I think it's now open to other departments, few other departments as well. So projects like that would allow you to get your hands dirty. And doing those projects would show you that what you learn in the curriculum would not just be sufficient, and you have to go beyond that. So person coming out of such a project would end up being a problem solver rather than just a graduate. So I would advise you to go beyond your coursework. And this does not apply only to academia. You should do other things as well, for example, sports. So that was something I did during my undergrad as well. So I did basketball, and I ended up captaining the university side during my final year as well. So sports would give you a very different perspective and allow you to develop a host of skills other than what you learn inside the classroom, working with people, leadership, and whatnot. So do those things during these 4 years, and doing those things would allow you to discover your true capacity. You know, if you just, I'm sure most of the people here who end up coming to the University of Moratuwa do have the capacity to just go through the coursework required by the degree program with very quite easily, I'd say, to manage the coursework and graduate. But the challenge is, and I'm sure you have the capacity to do very much beyond that. And by doing that is how you discover your true capacity. If you don't do that, you will never find your true capacity. The 4 years in the university is the best place for you to find that capacity and then use it after you go out, whether it be in the industry or the research center. and you could gain research and industry experience. So we have a lot of lecturers. If you come to the mechanical department, in all these areas that I told you, we have expertise inside the department, people who've done world-class research and are now inside the department working and teaching you guys. So you can always approach them, and not just the lecturers, even students or graduates who go into higher studies and industry. So you can always talk to them and help with their research, for example, or go approach them with your own ideas. And these would allow you to gain valuable research, research experience, and industry experience, of course, you can gain through internships that, again, you could do, is also required, I think, when you're in the university. And the other thing I want to highlight is to learn to communicate. And nothing you do would be valuable unless you learn to tell it to someone in a way that they understand. So that is also another key thing. So my final message is that mechanical engineering would give you a very powerful foundation. And I also wanted to tell you something, that there's a myth that mechanical engineering is mostly garage work, metal work, workshops, and things like that. But that is not the case. As you saw, I went through a lot of fields here. There are a lot of things outside of workshops, garage work, that would require you to do a lot of simulations, a lot of analysis, a lot of mathematics, and all these things. So it's, in fact, just a myth that mechanical engineering only requires physical work in workshops and garages and things like that. Yeah, so another important thing, if you do mechanical engineering, it's quite broad. It's a very broad field, as I highlighted earlier. So it does not lock you into one career path. It opens up a lot of doors for you. And if you are unsure of what to do at this point, and have some passion and have some liking towards things inside mechanical engineering that I told and that you may have heard before, choosing mechanical engineering would not lock you into any one path. It would, in fact, give you a lot of options down the line, whether it be after graduation or even inside the department. You can choose different specializations. And I know for a fact that there are other streams coming in as well. So apart from aeronautical and the mechatronics streams that you might have heard of, there is automotive engineering, biomechanical engineering, and also naval architecture and marine engineering, which would be, I don't think they are open to you guys, but these are streams in the works. And I think the curriculums are already developed as well. And in the future, there would be more resources inside the department being developed, targeting those streams. So, in the future, students would obviously be able to specialize in those streams, but I don't think you guys would get that opportunity, and we didn't get it either. But you should see, if you go into the department, you should see resources being allocated and developing in those fields. So if you are interested in those fields, there would be more in the department in the coming years, specifically along those streams as well. So at this stage, I would advise you to build fundamentals, explore widely, and keep learning continuously. I want to finish by saying that the best engineers aren't defined by their field, but rather by their ability to solve problems. So as Dr. Isuru also said, be a problem solver. So that is not specific to any department, but your ability to solve a problem. And it is, in fact, very surprising that most engineers today, although they have a degree, not really problem solvers. Some are just able to execute a order when they are given, for example. So I want you to be problem solvers, not just engineering graduates. All right, so thank you. So I hope I gave you a broad picture of mechanical engineering. I did not want to go into any specific research in detail. And yeah, so feel free to reach out to me through LinkedIn. I've listed my personal email here. you can always approach me. So, all right. I wish you luck with your decision, and I think we have Nadun, my friend, also who will tell you more about the industry next.
Thank you, Mr. Prabhatia, for that insightful academic perspective. Next, to share experience from the industrial and practical application side, let's invite Mr. Nadun Vijay Singh. Mr. Nadun is a University of Moratuwa mechanical engineering graduate, currently serving as a mechanical engineer at LTL Holdings. Mr. Nadun, over to you.
Hi, good evening, everyone. Let me share the screen here. Yeah, I think you all can see the screen. So to begin with, let me introduce myself. I'm Nadun Vijay Singh, and I'm currently working as a mechanical engineer at the Yugadanavi Combined Cycle Power Plant under LTL Holdings. So to explain about myself, I'm kind of a practical guy. So unlike most of you, before I joined University of Moratuwa, I had the dream of becoming a mechanical engineer, and I had the passion towards mechanical engineering. So at the first year, after the final examination, I had more options to apply to, but I stick with mechanical engineering because of my passion. So, unlike most of you guys must be wondering which department to choose and what to do for your future. So, what I have to say at the beginning is to follow your passion. You have to understand what the departments will provide, what you require to follow that department's course. So, after getting that idea, you will be able to identify that whether that suits you or not. So, going into the mechanical engineering department of University of Moratuwa, we had three specializations when we were at the University of Moratuwa. I think that's the same for you as well. As my friend Prabhati mentioned, I have also heard of the new fields that are coming to the departments, specializations actually. That's good, but I don't think that you will be able to get the advantage of that. But anyways, if that goes on, you will be able to get the advantage of the improved laboratories and everything. So the major three specializations that are available in the University of Moratuwa is the aeronautical engineering stream, which focuses on aerodynamics, aeronautics, and gas turbines and propulsion. So apart from that, as the ENTC speakers mentioned, we do have the mechatronic field, which if you have the interest towards mechanical systems along with the electronics and electrical systems, this would be a good opportunity for you And apart from that, we have the general stream, which is basically a wide area which covers almost all the fields. I mean, it's a broad area, as Prabhati mentioned, which includes thermodynamics, fluid mechanics, structural designs, manufacturing, and many more. So I won't be going towards the academic side of the degree program, because my friend Prabhati has already explained you the curriculum. I mean the courses that you will have and the research opportunities that you will have if you follow the mechanical engineering department. So I will be focusing on the industry, and I will be basically telling you guys my experience and how I transitioned from the university life to the industry. So I've been working in the University of the Yugadanavi Combined Cycle Power Plant for 3 years now. So to proceed with how I transitioned from the aeronautical engineering stream to LTL Holdings, the combined cycle power plant. The basics were based on the academic foundation. So I followed aeronautical engineering stream because I had the passion towards aeronautics, gas turbines, and propulsion. So with that, with the mechanics of with the knowledge on mechanics of gas turbines and turbine engines, I was able to utilize that on the power plant application, because as the Yugadani power plant is utilizing 2 gas turbines and 1 steam turbine working together to generate power. Under LTL Holdings, we have several power plants as well. We are the largest individual power producer in Sri Lanka. So LTL Holdings covers power generation in Sri Lanka, Bangladesh, Nepal, and Maldives. And apart from that, we have the South Asia's largest transformer manufacturing facility and the Sri Lanka's largest galvanizing facility. So with this view, I just wanted to tell you that there are good opportunities in Sri Lanka as well, apart from overseas opportunities. I'll talk about overseas opportunities in the upcoming slides. Anyways, you will be able to get to, if you are performing well and you have what it requires, at the end of the degree, you will be able to get a good offer in Sri Lanka itself. So moving forward, when it comes to the my day-to-day activities in the power plant, so my scope, along with another mechanical engineer, covers the entire power plant mechanical maintenance. So this includes gas turbine and steam turbine maintenance, along with the power plant other equipment maintenance as well. So for the 3 years, I have been able to experience almost two gas turbine hot gas path inspections, 3 combustion inspections, and 1 major inspections. Where in a major inspections, we will be able to rip the entire machine, and as you can see in the bottom images, get the entire unit out. So in this case, we are talking about heavy machinery maintenance. We are talking about 40 ton rotors and the temperatures and pressure levels of 510 degrees of Celsius and 210 bar pressure. So with all these, I just wanted to highlight that the fundamentals that you learn in the university matters when it comes to the industry, even when it comes to the research as well. So fundamentals are the things that you need to focus on during your university study. Also, another part that I am covering in the power plant itself is NDT inspections. I need to talk about this NDT inspection scope specifically because this is one of the major things that I've been able to grab or gain experience during my training at Sri Lankan Air Force. So what I needed to highlight in this point is you need to grab the maximum out of your training experience along with the lab experiences. So the experience that I gained during my training at Sri Lankan Air Force in undestructive testing helped me to develop the facilities in the power plant itself. When I joined the power plant, there were no facilities in the NDT scope, but we were able to develop the facilities and it's in a quite good level now. So moving on to the condition-based maintenance section, I just apart from the other scope, the other parts that I am covering in the power plants, this is one of the major things that you need to focus on because you see, as Prabhati mentioned, mechanical engineering, the myth is that it is almost like garage work, but yes, you do have to engage yourself in practical work because without a practical experience or without getting your hands dirty, you won't be able to get the core mechanical knowledge. So along with getting your hands dirty, we have under mechanical engineering in the industry, we have tools and technologies that we use. For example, under condition-based maintenance in our power plant, under LTL Holdings, we have the largest condition-based maintenance team in Sri Lanka. So we do have some equipments and tools that are not available in India as well. So that's something remarkable if you talk about the industry in Sri Lanka because you see with the level that the country is at now, having a technology at that scale is quite difficult. So when it comes to condition-based maintenance, what we do is it's basically reliability engineering. What we do is we try to identify a defect before the machine fails. So we monitor and trend vibration, ultrasound monitoring, and thermal images of machines. Apart from that, we have loop boil inspections to identify the condition the machine is at. So we will be able to avoid the unpredictable breakdown. So I just wanted to highlight in this that we are not just under mechanical engineering, we are not just focusing on repairing something that is broken. So we need to get innovative and develop. There are tools and methods that are developed to diagnose faults before they fail. Likewise, when it comes to the industry, it's evolving. So you have to learn every day to move on with the industry. Like when we are talking about your degree, you are spending 4 years in the university itself. During the university, the technology will evolve. Uh, there will be technologies that were not there when you were at the first year. So you have to evolve and learn every day and move on with the. If you are focusing on the industry and also the academia, you have to learn every day to move forward. So if I talk about the one thing that I needed to mention specifically is, as Prabhat mentioned, you guys are capable of doing the degree. That is, there is no question in that. You are capable of doing the degree and get out of the university without an issue. But you have to. My opinion is that you have to get out of your safe zone, comfort zone, and you have to challenge yourself and try to do something that others do not do. In the Department of Mechanical Engineering, you know that you have several projects. You have the US Challenge, IMECI US Challenge team, Team Falcon Racing. Batches prior to us, we had Team Shark Engineering as well. And apart from that, you have several societies and sports in university, like Isaac in Sri Lanka, Isaac in University of Moratuwa, Rotaract, and sports, many more sports. So you have to engage yourself in something. I mean, you have to challenge yourself because I have been to interviews in the University of Moratuwa to recruit students from the, I mean, recruit graduates from the university. I have been to 2 career fairs. What I have seen, sorry, what I have noticed during the career fairs, during the interviews are students who are engaged in these projects, or someone who is engaged in some kind of extracurricular activity always uh, gets ahead of a person who is focusing on his transcript when it comes to the industry. So you have to develop yourself with by focusing on extracurricular activities as well. So talking about the industry opportunities, when it comes to the mechanical engineering department, it's a broad field. I mean, there are robotics and everything, aeronautical, robotics, and general streams. So there are variety of, I mean, wide range of opportunities available in the industry. So at the moment, power generation is kind of a top demand field because there are a lot of projects going on, and LTL, CEB, and Aitken spins. These are several examples only, but there are projects going on. There are projects to develop the energy, I mean the power grid in Sri Lanka. So you will have a good opportunities. You will have good opportunities in power generation field itself. And then comes the apparel and textiles field. So in these fields also, like in the major companies like Mars, Brandix, and Mars and Brandix, you will have opportunities, huge opportunities. Apart from that, we have FMCG and manufacturing. So heavy machinery maintenance and high-speed production optimization at Unilever and Haley's. Like in the companies like Unilever, Haley's, you will have opportunities. And when it comes to MEP and marine, Colombo Dockyard stays at the front because you will have a wide range of opportunities at Colombo Dockyard as well. And along with that, you have Ceylon Petroleum Terminals, CPC, and Sapugaskanda refineries. There are a wide range of opportunities available. You can decide the field that you are focusing on. I mean, during the degree, and during the final year, you will be able to specialize on that field. So moving on, the points that you need to take home with you includes, as I mentioned several times, fundamentals is the major thing that you have to, is one of the major things that you have to focus on, because technology, yes, with time technology involves, but the laws of physics do not. So you have to develop and master your fundamentals, so you will be able to evolve with the technology. And as I mentioned during the presentation, you have to gain hands-on experience, and to do that, you have to actively engage in the lab sessions, get your hands-on experience on the measuring tools and the tools that are available in the laboratories, and the technologies available in the laboratories. Apart from that, you have to utilize your industry training experience to the maximum. I have provided a personal experience on into that as well. Apart from that, as I mentioned at the beginning, you have to follow your passion. Do not get into the mechanical engineering department if that is the only choice that you have. That is not going to work well. You have to get into the mechanical engineering field if that is your passion. If you are interested in mechanical engineering field, get into the mechanical engineering department. If not, please don't, because that won't work well. Apart from that, as I mentioned, with the extracurricular activities and projects, develop your other skills, because it doesn't matter how good you do when it comes to project or anything in the industry or in the in a research. You have to communicate and showcase that what you did. And apart from that, you have to develop the soft skills to use tools, uh, and yeah, apart from that, the communication, mainly the communication. So those are the things that I needed to highlight when it comes to the industry. So thank you. If you have any questions, you can ask in the chat. I'll drop my contact number and my email address in the chat. If you need, you can reach me out. I think there are 4 questions. I think one has asked, so how can we choose one of them? I mean, from an exam or by ourselves? I think they are, he is Vinu De Silva is asking about the streams. Correct me if I am wrong. The basic, what happens is when you get into the mechanical engineering field, in order to get to a stream, you have to apply. So what happens is you have the rank from the first semester exam, and based on the rank, you will be selected. I mean, doesn't matter that let's say your rank is 350 and you are the 10th student that is selected to the mechanical engineering department. And all the other students have already applied to the mechatronic engineering, and you are applying to the mechatronic engineering as well, mechatronic specialization as well. So you will get selected. But if you're the 11th and already 10 students have been selected to the field, then there will be an issue. So that will be you will be selected based on your first semester exam performance. I think I have answered the question. If that's not what you have asked, please let me know. Yeah, so what about the job opportunities apart from the plant areas like automotive side? I have already explained about the about several areas. As I mentioned, mechanical engineering is a broad scope, has a broad scope. So when it comes to the automotive side, specifically, you have Vega and KD Rice Motors and also Demo and several automotive sections are automotive companies are hiring. So I have my friends who are working in these fields and they are doing good. And also, when it comes to the industry, you don't have to limit to Sri Lanka. You have opportunities in overseas. Of course, you have to gain a bit of experience or do a master's. But um, if you have experience, let's say 3 years experience in specific field, you will be able to apply for foreign opportunities as well because most of the engineers that are available in our power plant have already applied for foreign opportunities as well. They are doing well in foreign countries as well. Uh, we have another with my current GPA, I could not secure an aeronautical exam, but I wish to do that. So tell me what is the way to so what he is asking is he with the GPA he is not able to secure the aeronautical secure and position in aeronautical engineering stream, but he like to do that. Way to be an aeronautical engineer. Okay, so the thing is, I don't know whether you have. How did you check the whether that you are not able to secure a position in the aeronautical engineering stream? Let's say there are 20 students who are interested in mechatronics and aeronautical engineering stream. For an example, I was the 10th in the mechanical engineering department in our batch. I had the opportunity to choose mechatronics, but I did not choose that because of my personal interests. Likewise, there will be students who are not willing to follow the aeronautical engineering stream, although they are in the top 20. Uh, that might give you a chance. Apart from that, if you are not selected, you don't have to give up because I personally know students in my batch itself who has knowledge on aeronautical engineering stream than the students in the aeronautical engineering stream. It's always the passion, as I mentioned. You have to uh, uh, improve your knowledge and learn with the technology, move with the technology. Because when it comes to aeronautical engineering stream, the technology is widely changing and it's rapidly evolving. So you have to be moving with that. And apart from that, you will always be able to follow an aircraft maintenance engineers program, private degree, which is available at Sri Lankan Airlines and also at Ratmalana Airport as well, which will not cost that much. That is another option. And also, you will be able to apply for internships at Sri Lankan Airlines. So in that case, also, you will be able to help yourself. I think I answered that question as well. What steps should I take to go in the aerospace side? When it comes to the aerospace side, it's quite different. Like if you're talking about research in the aerospace area, it's not the aeronautical stream you have to focus on. It's something different. But following on aeronautical stream will help you to get into the aerospace side. But it's not the same. Aerospace and aeronautical engineering streams are different. Most of the research opportunities available in, let's say, in USA are basically focused on aerospace, not aeronautical. So having a specialization in aeronautical will not ensure the position in aerospace research, but it will help rather than having a general mechanical engineering degree. So if you're focusing on research or a job in aerospace side, you will have to follow aeronautical engineering stream and then maybe a master's in aerospace. That will help you. let me come back to that question. We know people say that there is a very busy academic schedule in mechanical engineering department. Can you give some advices upon managing extracurricular activities alongside with the academics? Yes, yes, that's what I am saying. As Prabhati mentioned, you have the capacity. You are capable of doing the degree without a blink. It's easy, I mean, for you guys. But getting out of that comfort zone and challenging you is the thing that you need to do. So if you are to do some extracurricular activities, you have to sacrifice some things, some other things. Let's say when I was in the Team Falcony Racing along with Prabhatia as the Chief Technical Officer, we sacrificed a lot. We sacrificed parties. We sacrificed. I'm not saying that we enjoyed. We did not enjoy. We enjoyed because when it comes to mechanical engineering department, it's a department that is uh, enjoying the moment that to its maximum. So we were there at the parties and everything. We were along with the projects. I was the department representative and as well as aeronautical engineer, as well as the aeronautical engineering stream representatives. Stream representative. If I was and Prabhatia was able to do those things, and to explain about Prabhatia, he was the captain of the basketball team in his final year, and he was the chief technical officer of the Team Falcon Racing, along with a GP of 4.09. So if he can do it, you will be able to do it, because managing the activities, extracurricular activities along with the academics will be possible if you are focused on both. You can't focus on just the extracurricular activities or just the academics. You have to know when to focus on the academics and when to focus on the extracurricular activities. And apart from that, you have to have a clear schedule in your mind. Let's say there's an exam coming up. You have to prioritize the academics. And in the free time, you can use, I mean, the free time that you have to, I mean, you will have free time. Yes, the academic schedule is busy. All those things are correct, but there will be time. Because I'm saying this because we were able to do this and we were able to follow the extracurricular activities along with the academics. So this won't be a problem. What you have to do is learn how to focus on the thing at the right moment and have a clear schedule on your head. So is the salary range good in Sri Lanka, and is it hard or easy to get a good job in Sri Lanka, and how to get a job overseas? I mean, to be recognized by them. So first, to get a job in overseas, you have to have a good at least a master's degree, or you will be able to get get into an overseas job if you have let's say it's not like when we passed out. I mean, when we graduated, it was quite different, but the with the technology and everything, now it's quite different. You can apply for job opportunities. You will be able to get recognized by overseas job opportunities, because several friends of mine are working in overseas. I mean, they are working overseas, and they have been able to get into a job in Sri Lanka at first, and within a year or so, they have been able to go abroad. That's possible. And when it comes to the salaries in Sri Lanka, let's say as a I'll talk about LTL Holdings, because I have no idea about other job opportunities. So your basic starting salary will be around 250 and so on. And after 3 years, you will be able to get a salary above 4 lakhs. What I am saying is there will be ENTC jobs or software jobs that will pay at the beginning of your job at the beginning of the job, but with time you will pass them. I'm telling this by experience. You will be able to pass them within 3 to 4 years for sure. Don't worry about the salary. Focus on the or focus, because if you have developed a good career, good I mean CV, good CV, you will be able to with I mean, I'm not just talking about the CV. If you have good experience and project experience and good GPA and everything, you will be able to negotiate the salary with the industry. Okay, so don't worry about the salary. Focus on developing yourself, and with that you will be able to get anything. How we go through to the electrical side. I have a question from I the name that is showing here is Dila, but I'm not quite sure about the question. How we go through to the electrical side? What are you asking about? Are you talking about the mechatronic side? If you can elaborate in your question, I will be able to answer. What are the things considered when recruiting to Falcon E team? That's a question that is difficult to answer, because when we were in Falcon E racing, things are quite different. We were focusing on the practical experience that you have, and mainly the passion that you have. You have to develop your skills. If you have a, let's say, you are competing with your batchmates, right? So let's say you have a special uh, ex, uh, experience in welding. You are capable of doing a TIG weld. Okay, that would be a plus point for you. So when it comes to the Team Falcon E-Racing, it's not about just academia or your GPA. It's about practical experience and how you handle things. So I know a lot of people who have been to those projects and left the project at the middle, at the because they are, I mean, there are several reasons. So what you need to do is you need to develop yourself from the beginning on practical aspect, and you need to have a practical knowledge along with the technical knowledge. So when we were in Falcon Racing, what we were focusing on were the practical experience and the technical knowledge. Prabhati, if you have anything to add, you can add to these questions, because you were in the Falcon racing as well. The question is, what are the things that you consider when recruiting to Falcon racing?
Yeah, I guess that depends, as Nathan said, depends on the current team's requirements at that point. So it's main thing we were looking at, I think, was the passion. We would ask questions from people on racing and Formula One and things like that, just to check whether the guy or the person interviewing was in fact passionate about the project. So that was the main requirement. And we believe if you have the passion, you could learn any difficult technical skill along the way. And that is what we have to do in the Falcon 18. You have to keep learning on the go. You end up with different problems every day. So yeah, that would be learning would be possible. Passion would be the main requirement, I'd say. But Nadun, I'm not sure if we do have the time to keep answering these interesting questions, but the organizers can tell us if we could or we could stop.
There are 3 more questions, Prabhadia. If there are, I mean, the moderator is here, right? If it is it okay if we go ahead with the questions, or do we have to wind up?
I'm not sure. I will have to ask about it, and I'll let you know.
Okay.
Yeah.
In the meantime, Prabhati, I think it's better if you answer this question. There's a question that, so if we choose general field on mechanical department, what things do we have to learn? Because Prabhati has many more experience as a lecturer than me, so he will be able to explain it.
All right, what things you have to learn. So there is a general curriculum for the mechanical degree, and the streams would also be, I'm sure you have been told about these by Dr. Hill, I think, conducts the field familiarization session. So you should have gotten a proper idea during your field familiarization session. So to add to that, though, I think the streams do have a core mechanical component as well. So the core mechanisms, mechanics, design, thermodynamics, fluid dynamics, all the core parts or the core subjects inside mechanical engineering would be covered for all the streams without a difference. But the streams would then be additional specialized modules that are specific to those streams. For example, mechatronics students would have to do robotics and control systems and things like that in more detail. But for the general people, they do get a more wider choice, I'd say, to choose what they want to do when they say come to the third year or the fourth year. So you will get a good solid foundation of the core mechanical modules. And then if you want to go into the aeronautical side also, as I think one student asked, you could maybe pick some modules related to that as well. If you want to go into the automotive side, you could, I think there are a couple of modules you can do inside the department when you come to the third and fourth year as well. If you want to go into the biomedical side, you have modules related to that. So choosing the general field would open you up to a lot of possibilities. And if you want more details, I would advise you to go just search on Google the curriculum for the degree, the mechanical engineering degree, and also the streams. So you get to see all the modules in detail, the names. Then if you go inside, I'm sure you can see also maybe what is covered inside each module. So you could do that if you want more details. And feel free to reach out if you have any more specific question.
Prabhatia, the moderator has asked us to wrap up the session.
Yeah,
So
all right. Yeah.
we have I have already shared my contact number and the email address. The email address must be changed to gmail.com. We have shared the contact details. If you have any further question, I have already seen several questions. You can reach me out on the on WhatsApp, or you can reach out Prabhatia as well in LinkedIn. We will help you out. Thank you.
Okay, thank you, Mr. Nadun. Thank you, Mr. Upadhyay, for that interactive Q&A session. And that wraps up our sessions for tonight. A huge thank you to Sahan Kure, the FSU, and each of our distinguished speakers from Electrical Engineering, ENTC, Material Science and Engineering, and Mechanical Engineering for taking time out of their busy schedules across different time zones to guide the 25th batch. To the 25th batch, we hope these sessions gave you clarity, inspiration, and answers to your questions. Seniors, if you need any further guidance. Thank you for joining us. Have a fantastic evening ahead and good luck with your field selection. This is Devin Hemaratna signing off. Thank you.